Hey, how's it going everyone? My name is Ethan, or I go by Unknown Coder here on YouTube. I am a senior software engineer at one of America's big three automotive manufacturers. And this year I made myself a New Year's resolution to get way better at typing and become a much more efficient programmer after it took me several months to edit out all my typing mistakes in my previous merge stack tutorial. And enabled to become a more efficient developer, I decided to take the leap into the world of NeoVim. As I was learning Vim and trying to find a configuration that was right for me, I came to the realization that most general purpose starting points were created for programming languages like Python or JavaScript, and any setups for Java lacked instruction on how to get everything working properly. That is exactly why I'm making this guide today. I want to share everything I learned while configuring my setup and show you all how to build out base configuration for Java full stack development while keeping it as simple as possible. The goal of this configuration is, as I mentioned, to start simple, but also provide you nearly all the features of your old IDE. And the great thing about this configuration is that it is easily updated and molded into whatever you like it to be. So if that sounds great to you, go ahead and get straight into the configuration after I give a few shoutouts to some of the developers that led the way to this configuration. First up is TJ DeVries and his Kickstart the Nvim project, which served as a foundational starting point for my configuration. While I simplified many aspects of his project, his video on the starter configuration is an excellent resource and I highly recommend checking it out. The link is in the description down below. Another source of inspiration was the Rad lectures on YouTube. Watching his NeoVim configuration video provided valuable insights that I incorporated into my own setup. And lastly, Chris at Machine and his launch to Nvim configuration also played a significant role in shaping my approach. While I trimmed down his configuration to suit my needs, his setup is another great starting point for exploration if you're interested. I'll leave all the links to these developers and their configurations down in the description below. They offer more technical insights into NeoVim, as well as you might be able to find additional plugins and features that you want to enable based on their configurations. Now with all that being said, let's go and hop into all the technologies that you'll need to get this configuration working. As I mentioned previously, before we dive into the tutorial, let's ensure we have all the necessary software installed. Due to differences in operating systems, I won't cover the download and installation process for each and every software. Instead, I'll go ahead and assume that you have them installed, or you can find the installation instructions online. Firstly, we want to ensure that we have Git installed. This, of course, is a standard development tool, and since you're watching a NeoVim configuration video, I trust that you likely already have it installed. If you somehow don't have it installed already, you can go ahead and head over to git-scm.com and follow the instructions that are tailored for your operating system. Typically, this is as easy as just following the steps in the installation and you're good to go. You can just keep all the defaults. Next, you'll need to install NeoVim. NeoVim is a fork of the original Vim text editor, which offers improved extensibility and usability. It features a built-in Lua runner for easy configuration, as well as a built-in LSP client for semantic code inspection and refactoring. You want to go ahead and visit the NeoVim GitHub repository in the description below for installation instructions for all operating systems. I will say that for Windows users, I highly recommend using Windows Subsystem for Linux for smoother installation of NeoVim and just working with it in general. And you can go ahead and find tutorials online for setting up Windows Subsystem for Linux. However, if you do decide to forego the WSL approach, I do want you to prepare for potential issues that pop up, and I probably won't be able to help you out because we are going to be basing this off a Unix-based environment here in this tutorial. Additionally, you also need to install a nerd font for better terminal experience. Basically, what a nerd font is allows you to have better fonts, as well as having some web dev icons or just general icons in general that will kind of spice up your terminal experience. You want to go ahead and visit nerdfonts.com to explore and download a monospace nerd font with added icons. It is very important in this step to make sure you do get a monospace font because terminals are inherently monospace, and if you have some characters that are a little bit larger, it's going to throw some spacing off and you do not want that. Personally, I use JetBrains Mono, but you can go ahead and feel free to choose whatever font you want and then do some research on your own to go ahead and figure out how to install it. Some of the terminal emulators are pretty easy to install it, including Windows. All you have to do is kind of go into the settings and set up whichever font you use, but I know everything's different, so again, go ahead and figure this out on your own and then come back to the video. Another essential utility that you'll need is called ripgrep. Ripgrep is a command line tool for recursively searching directories for regex patterns while respecting your git ignore. It's basically a more efficient grep, and it's going to allow us to kind of search for files and text inside files later on. Once again, you're going to want to go ahead and visit the ripgrep GitHub repository and go ahead and follow the installation instructions tailored for your operating system. It should be fairly simple. Lastly, we want to make sure you have all the necessary tools for your specific development language installed. Since this video is focused on setting up NeoVim for Java full stack development, you will of course need your Java tools. Specifically, you will need Java 17 or later for the language server we're going to install in a bit. You'll also need Node.js and NPM for your React development, as well as your TypeScript and whatever else. Of course, go ahead and also adjust for any other languages that you plan to work on later. Now, once you've met all of your prerequisites, we can go ahead and open up the terminal that that you're planning to use. So I'm going to go ahead and open up my terminal instead of WSL, and we can go ahead and navigate to the home directory, which I'm already at. Once again, if you're using a Windows machine, just go ahead and research where NeoVim will automatically look for your configuration at. However, on Unix-based systems like Linux and Mac OS, NeoVim is going to go ahead and search for configurations inside the .config directory in the home directory. We can go ahead and see if this exists inside of our home directory by saying ls-a and hit enter. You can see that I already have a .config directory here. If you do not have it, you can also go ahead and create this with mkdir and then .config. I'm not going to be running mkdir.config because I already have it, but if you don't have it, go ahead and do that. And then for Windows users, just go ahead and make sure you find out where NeoVim is going to be looking at. Now, once we do have this .config, we want to go ahead and cd into that .config, so cd.config. And then ls, and we can see that we have some other configurations here. Yours might be completely blank, or if you've been working with some other stuff, you might have some things in here. I've gone ahead and just nuked my entire NeoVim configuration completely. That way we can go ahead and start from complete scratch, and you guys can follow along with me. So now what we're going to want to do is NeoVim is specifically going to look inside of this .config directory for a folder called .nvim. So now NeoVim is specifically going to look inside this .config directory for another directory called nvim. So of course, if you didn't have this before, or if you're just starting out fresh, you're probably not going to have this. So let's go ahead and say mkdir and nvim, and then let's go ahead and cd into this nvim. So cd nvim ls, it's obviously empty. Now that we're inside of our nvim directory, we want to go and create a file called init.lua. So we can go ahead and say touch init.lua, hit enter, and then if we ls, you should see that we have an init.lua inside of our .config/nvim directory. This file serves as the main configuration file for your NeoVim setup, and we're also going to go ahead and notice that this is a Lua file. This is because NeoVim uses an embedded instance of Lua for configuration, making it highly customizable. And if you're unaware, Lua is a versatile scripting language known for its simplicity and extensive documentation. NeoVim's use of Lua instead of Vim's old arcane language contributes to its popularity. So, as we just mentioned, the init.lua file is the first thing NeoVim is going to look for on startup. You can go and verify this by entering the file with nvim init.lua. So nvim init.lua. Now we're inside of the init.lua and it's completely bone stock. And what we can go ahead and do is we can just add a simple print statement. And whenever we open up NeoVim again, we should see it. So let's go ahead and say print. And we're going to go ahead and just say welcome to the NeoVim journey, like so. And then go ahead and close this off, WQ, to go ahead and save and quit. So now if we go ahead and open this back up, at the bottom of the screen, you can go ahead and see that there's a welcome to the NeoVim journey. So basically what happened is whenever we start up NeoVim, it goes inside of that .config/nvim directory. It's going to look for this init.lua to load up any configuration files automatically and then set that up for us. So I'm going to go ahead and delete this with DD, go ahead and W to go ahead and save that. And then we'll go ahead and just close out of this file. So we can go and talk about our folder structure or directory structure for our configuration here. So there are various different approaches for organizing a NeoVim configuration. You could go and opt for a single init file akin to the kickstart.nvim, or you could segment your files into different layers and directories and so on and so forth. But for simplicity, I've chosen a straightforward approach that kind of bridges the gap between the two. We're going to go ahead and store our main configuration code in one directory. We're going to keep all of our plugin related files in another directory. This is going to strike a balance between separating the plugin and non-plugins files while also maintaining simplicity for easy understanding. So to go ahead and establish our configuration structure, we need to create additional directories. NeoVim allows for importing code directly from a Lua directory of your configuration using the directory.file convention instead of having to specify the entire import path. With this in mind, let's go ahead and create a new directory called Lua within our .config/nvim. So we're going to go ahead and say mkdir, and we're going to go ahead and say Lua, and then let's just go ahead and cd into this Lua directory like so. This is going to be empty, and then what we want to go ahead and do is we want to go ahead and create our two different layers for configuration. So first thing we're going to do is we're going to make a folder or directory for all the configuration files. So let's go ahead and say mkdir config. And then we also want to go ahead and make a directory called plugins for all of our plugin data. So then we're going to say mkdir and plugins. So now if we ls, you can go and see that we have plugins and config, and this is inside Lua. If we cd ... we can ls, we start init, and we see Lua. So basically we have our .config in the home directory, we have /nvim inside of our .config directory, and then inside of nvim we have our init.lua, which is our main file for loading in Lua scripts, and then inside of our Lua directory, our init.lua can go ahead and import any scripts very easily without having the entire file path. So now since we're back into the root directory of our nvim configuration, let's go ahead and just write nvim dot to go ahead and open up NeoVim in its purest form. And now you'll go ahead and see our netrw, and if you want to kind of see the load up screen, you can also say just nvim with nothing, and then this will just kind of show you the main splash screen. However, I'm going to go ahead and open it up to nvim dot, and then we can go ahead and see netrw. So basically netrw is Vim's default package explorer. So you can go ahead and kind of see our different folders. We can go into different files, we can quit. I don't 100% know how to actually use netrw that well, but you can go ahead and see config, there's nothing in there, go back, plug in something in there, go back from here and here. So the thing is, we are going to go ahead and disable this very soon because we're going to be using a better and more efficient package explorer, but I did want to go ahead and show you this older and more arcane way of navigating through files. A lot of people don't even use file explorers whatsoever. I think that what they're actually useful for is like creating new files and whatnot. But with that being said, we can go ahead and get started and start working on our different configurations and get this thing started. So let's go ahead and do that now. So still inside of NeoVim here, we're going to go ahead and start making some files. So since we're inside the root, to go ahead and create a new file, we can go ahead and say :e, and this is going to go ahead and edit a file. And I'm going to go ahead and say ./lua. So this is going to go ahead and make a file inside the Lua directory /config. So then inside the config directory, we're going to go ahead and make an options.lua file. So this is going to be a file that's going to serve to configure some NeoVim appearance and behavior properties. So let's go ahead and hit enter to open this up. And I just like to make sure that this actually saves because sometimes the .edit doesn't work. So let's see if it actually worked. So let's go and quit, and then let's go ahead and ls /lua and then /config. And make sure options is there. Terrific. That's what I wanted to see. Sometimes the edit is kind of finicky and doesn't like to work and doesn't like to save and whatnot. So that is perfect. So now we're going to go ahead and just start going through and filling out some of our basic options inside the options.lua. So I do want to go ahead and mention that I am going to be pasting in code while explaining while we're including it inside of here or inside of any other files. We're going to be going through the code pretty quickly here because I don't want this to be a super long configuration video. That and because everyone can either pause the video to kind of see what I'm doing, or you can go ahead and just grab the code from the GitHub repository linked in the description down below. So with that being said, let's go ahead and get into this. So the first thing we're going to go ahead and do is kind of modify our left side appearance here. So let's go ahead and I'm going to go ahead and bring in our comment. So this is going to be left column in similar settings. The first thing we're going to go ahead and bring in is line numbers. So to do that, we're going to say vim.opt.number is equal to true. This is going to go ahead and display line numbers on the left side of the screen. And next is one that you can either use or not use. Some people love it, some people hate it, and this is going to be relative line numbers. To do that, we're going to say vim.opt.relative number. So basically this is going to allow you to see basically the count above and below the line number that you're currently on. This will make it easy to say like, okay, we want to jump 10 lines up, we want to jump 10 lines to the left, 10 lines to the right, so on and so forth. So you could do that easily with our JKL, so on and so forth. Next, we're going to go ahead and set the width of the number line column. So this is going to be done using vim.opt.numberWidth. Again, this is just going to make it a little bit smaller. That way we're not taking up too much real estate displaying information, and we have more real estate to go ahead and put code in. The normal here is just 4. So basically just taking it down 2 spaces from tab to 2 spaces. If you want a little extra space, you can set that to 4. Again, this is going to be your guys' configuration at the end of the day, so you guys can change it and modify it however you like. I'm just trying to go through and show you all how I do things. Next up, we're going to go ahead and set the sign column on the left. So to do that, we're going to go ahead and say vim.opt.sign column equal to yes. And yes is basically going to always show the sign column. So the sign column is going to be even to the left of the number column. And basically this is just going to be some space to give us some information. And why we want this on all the time is because sometimes you might have some diagnostic. We're going to have some get signs to kind of show if files were modified or not modified or so on and so forth. So basically, if we don't have this always on, sometimes it's going to bump the code around depending on what line you want everything to be nice and uniform. So we're going to basically take up the same amount of space no matter what we do on the left side, and it's going to keep things nice and consistent. So next up, we're going to go ahead and set up some options for line wrapping. So we're going to use vim.op.wrap equal to false. So we're going to make sure we display everything on a single line. Again, if you want this to be true and you want to wrap automatically, you can go ahead and set that to true. This is just something that's typical for most configurations. Next up, we're going to go ahead and set up something that's really annoying if you don't have it. So something that can happen here with Vim is if you start getting a whole bunch of lines and you start scrolling up or down, sometimes you can't see the bottom of the code, or like it kind of gets too low and you can't really see what's going on. So to remove that, we can actually set scroll off. So we're going to say vim.op.scrolloff is equal to 10. And this is just always going to keep a specific number of lines above or below the cursor. And this is just great for like taking notes, or if you're trying to show things on the screen like I do. I don't want to get to the bottom and not be centered in the screen. So that's just what that's nice for. And we can also do it for the sides as well. So we always want to make sure we have so many on the left or right of the cursor as well. We can also use side scroll off. So that will say vim.opt.side scroll off equal to 8. Again, kind of keep things centered in the window so it's not as messy. Cool. So that's going to be all of our left column in similar settings. Next up, we're going to go ahead and take a look at some of the tabbing and spacing just to kind of keep things consistent. So the first tabbing spacing is going to be whether or not we want to convert our tabs into spaces. And this is kind of nice for like Git and stuff, because Git's going to try to do this anyway, especially with like line ends and different character stuff like that. So just to be safe, we're going to go ahead and set expand tab equal to true. And this is just going to convert all of our tabs to spaces, makes things more consistent, less characters, stuff like that, easier for Git to convert and whatnot. It's just kind of nice to have. Next, we're going to go ahead and set how many spaces we want our tabs to be, or different indentation levels, I should say. So to do that, we're going to go ahead and say vim.opt.shiftWidth. So this is basically whenever we go to a new indentation level, how many spaces do we want? So as a Java developer, I typically use 4. I know that a lot of maybe front end only people, or maybe people doing other languages, might not use 4. So again, put this however you want. You can either do 2, you could do 4. If you're crazy, you could do 8. I don't recommend it, but you can do whatever you like. This is your configuration. Next, we're going to go ahead and set how many spaces the tab actually is. So whenever you put a tab in yourself, so to do this, we're going to say vim.opt.tabstop is equal to 4. Again, Java developer, I've always used 4 spaces for a tab. I don't know, I just kind of having the space and separation and whatnot. So again, if you want to put this as 2, or if you want your shift width and indentation to be 2 as well, just make sure these all line up. Otherwise, it's just going to be kind of gross. And then finally, I don't fully understand why we need 2 of these. I guess it's just to be safe, but then we have one more for whenever you do hit the tab key. This is going to be vim.opt.softTabStop. Again, we want to go ahead and set this to 4, or match this up with these other ones. So if you have it at 2, just make sure all these at 2. Otherwise, you can get some kind of wonky behavior there. We don't want to have wonky behavior. We want everything to be more or less in line and consistent. So next up, we want to go ahead and enable smart indentation. So basically, it'll automatically try to indent things for you. To do that, we'll go ahead and say vim.opt.smartindent equal to true. Like I said, this is going to go ahead and try to automatically make indentation for you. And this is kind of where that shift width comes in. So whenever it indents something for you, it's going to add 4 spaces there. And then finally, we're going to go ahead and add enable line breaking indentation. So whenever the line breaks, we'll go ahead and indent. So you see this a lot inside of Java. Whenever you go ahead and, for example, maybe you're doing a map function with the lambda, it kind of indents whenever you break a line. So that's going to be the same exact idea, and it's just going to do that automatically for us. So now we're going to go ahead and just get into some general purpose behaviors. I didn't really know how else to label them. Our general behaviors. First off, we're going to go ahead and say goodbye to netrw, unfortunately. So the first thing we need to go ahead and do is disable netrw. So to do that, we're going to go ahead and say vim.g.loaded netrw equal to 1. We also want to go ahead and disable the netrw plugin. So in case that's still floating around or whatever. So this one will also be vim.g.loaded underscore netrw plugin equal to 1. Again, we're going to replace the netrw plugin shortly with a better one. And it's not going to be too many plugins in, so we're not going to miss netrw for that long. It's just going to work a lot better. Next, we want to go ahead and disable the creation of backup files. So this is just kind of icky and kind of gross whenever you accidentally close out of something, or you mess up or whatever, you just want to save, or if you lose it, whatever. So to do this, we're going to say vim.opt.backup equal to false, and this is going to save you a bunch of headaches with swap files and things like that. Next up, we want to go ahead and allow ourselves to use a system clipboard whenever we go ahead and copy paste. So to do that, we're going to say vim.opt.keyboard is equal to unnamed plus. Again, this is going to allow us to, whenever we copy into like using yank with Y, it's going to go ahead and copy it into the system keyboard. Now, something I do want to keep in mind is that on Windows Subsystem for Linux, this is kind of doesn't work 100%. Now, if you're using something like a Unix-based system that is like Linux or it is Mac OS, this is going to work a lot better. But because of the way that the emulator works in Windows, it can't really actually get the clipboard all the way over to Windows. It just is inside of the Linux clipboard. However, you can still copy from Windows into Vim. So just kind of keep that in mind. It's a little bit wonky, but it's kind of a good idea to have this in case you want to copy from Vim into something else. Or if you don't want that, you can go ahead and skip that as well. Next, we're going to go ahead and set up something for showing concealed characters in markdown files. This one is going to be vim.opt.conceal level. I don't 100% remember what this one does. I think this one has to do with either something to do with encoding characters correctly in markdown files. I had better notes on this, but I completely forgot what it was. So you could try it out. If you don't want it, you can go ahead and disable it. Again, this is your configuration. Next up, we're going to go ahead and set the file encoding for all of the files that open up in Vim. We're going to use UTF-8, and to do this, we'll say vim.opt.fileEncoding is equal to UTF-8. This is kind of just like a standard that most operating systems are going to use, so it's probably good to stay that way. Now we're going to go ahead and set up mouse support. So while you typically, whenever you're going to be developing inside of Vim, you're not going to be using your mouse, it is still pretty nice to be able to drag windows around and resize things. So to do that, we're going to say vim.opt.mouse is equal to A, and this is going to go ahead and enable all mouse support inside of NeoVim. Again, if you want to do on extra hard mode and only resize windows and whatnot using your keyboard, you can go ahead and set up Keymaps for that and whatnot, but this is the baseline tutorial, so we don't really get that deep into this. Next, we're going to go ahead and turn off our show mode or our display mode, and to do this, we're going to say vim.opt.showMode equal to false, and this is this little icon down here, the insert mode. And now this is something you could keep on for now. Maybe it's helpful for you, but as you get going, you're not going to need it. And the other thing is that at the end or towards the end of the tutorial, we are going to be setting up something called Lua Line, which is going to show you the insert mode anyway. So it's basically just showing it twice. So if you can just kind of get along without it here for the next however long tutorial ends, you're going to be fine because we're going to enable it later on. Next, we're going to go ahead and do a couple of things for Windows. So first, we want to go ahead and make sure that a horizontal split. So whenever we split the window in half horizontally, it's going to go ahead and open up below because this is kind of like a standard behavior. To do that, we're going to say vim.opt.splitBelow is equal to true. So once again, this is going to go ahead and force horizontal splits to be below the current window instead of above. And then the kind of same thing for vertical splits. So whenever you split it left and right, typically it's going to split to the right rather than the left. So to go ahead and do that, we're going to go ahead and say vim.opt.splitRight equal to true. And if you guys don't want this, if you really do want to split above or split to the left or whatnot, you can go ahead and say false on these or just not put them. But typically I'm pretty accustomed to them splitting that way, so that's how I want them. Next, we're going to go ahead and enable terminal colors inside of Vim. To do this, we're going to say vim.opt.termGUI colors, and this is just going to make things look more vibrant, and it's going to be useful whenever we get into things like color schemes and things like that. So this is a good thing to have installed. Next, we're going to have the timeout length, and this is basically for whenever you do key mapping, how long do you want to wait for it to stop registering key maps? So like, for example, we're going to set up a key map for like space, whatever. So if you hit space, how long do you want to wait until you hear another piece of information before starting or doing whatever piece of code or whatever mapped code that you want? So to do this, we're going to go ahead and say vim.opt.timeoutLength, and we're going to go ahead and set this to 1 second. That seems to be a pretty good length. You could try to tweak a little bit if you're really good on the keyboard. I think I've gotten it down to like 500 milliseconds and it picks it up just fine, but typically 1 second is a pretty good start. Next, we are going to go ahead and make it so we can undo things with the U key. So to do this, we have to go ahead and enable an undo file. To do that, we're going to say vim.opt.undo file is equal to true, and this is going to allow us to basically go backwards in time and undo things. So now we're going to go ahead and set up a couple other things. So next, we're going to go ahead and set up the update time for faster completion. To do that, we're going to say vim.opt.update time is equal to 100 milliseconds. Again, this is just for faster completion whenever you do like hit something, for example, hit a key map, for example. And then we're going to go ahead and set up a backup file to false because we do not want those backups, those swap files, that are annoying. So to do that, we'll say vim.opt.writeBackup is equal to false. And this is also going to prevent us from editing files that are being edited elsewhere. And finally, this one is completely up to you guys. If you like it, you can keep it on. If you don't like it, you can go ahead and turn it off. So this is going to be a cursor line, which basically just sets a line across your screen of where your cursor is at. To set that, we're going to say vim.opt.cursorLine equal to true. And this highlights the entire current line that you're on. Again, if you don't like the look of this, you can go ahead and turn this off. This is going to be your configuration. I'll probably say that like a million times, but please do what you like. If you don't like something I have here, fix it. It is what it is. Cool. So now we're going to have some searching behaviors. So let me go ahead and bring in my comment for our searching behaviors. So this is just going to be some general purpose things whenever searching for text inside of our files. So first we're going to go ahead and turn on highlight search. To do that, we're going to say vim.opt.hl search equal to true. And this is going to go ahead and highlight all of the word matches inside the search. Now the thing that you have to be careful about is it's really annoying to get rid of that highlight. So in the next section, we'll go ahead and make a key map to get rid of them. And along the lines of searching, we're going to want to go ahead and by default ignore the case sensitivity. So if we write in all lowercase, we want to also go ahead and match uppercase as well. So to do that, we're going to say vim.opt.ignore case is equal to true. So for most instances, if you just go ahead and write it in lowercase, it's going to go ahead and match any case of it. But if you do want to go ahead and explicitly match like uppercase, you can go ahead and say vim.opt.smartcase. If you set vim.opt.smartcase, what it's going to do is it's going to look to see if you explicitly made uppercase inside of the string, and then it'll start using smart casing instead of all lowercase. And that's going to be all of our configuration for just basic Vim behaviors and appearance. Again, if you guys want to add more here, that is perfectly fine. You can look and do a little bit more research or tweak these to whatever you want. So I'm going to go ahead and say WQA and write and quit everything. And then I'm going to go ahead and reopen Vim dots and then go back into my init.lua. So what we're going to want to go ahead and do is we want to bring in that file that we just did and make it run whenever we start up Lua. So to be able to do that, what we want to go ahead and do is we need to require this, and then it'll load it on startup. So to do that, we're going to go ahead and say require config.options. So now whenever NeoVim starts up, it's going to look in this init.lua file. It's going to say, okay, we need to go to the lua/config directory and then grab that options file and run that script and set all that stuff up for us. So let's go ahead and W this to save it. And then a way for us to go ahead and see these changes, we can say :source %. And that is going to go ahead and source this configuration file and go ahead and reload our NeoVim instance for us without us having to restart. So as long as I did this properly, and there's a good chance I could have messed something up, so it might take me a couple takes here. If we hit enter, you should go ahead and see now we can see what line our cursor's on. Again, if you hate it, you can add it, you can get rid of it. You can see line numbers. You can see that it looks like things might have changed slightly, maybe not. You can also see on the left side that we have like a little gutter, and that's where different information about code and get status can go. And then we can also see the line numbers and the relative line numbers. So we're on line 2, and one line above it would be up to here. That's going to go ahead and do the general appearance and behaviors of Vim. Next up, we'll go ahead and make a new file and go ahead and start setting up some of our key mapping. So let's go ahead and get into that now. Let's go ahead and get into our key maps here. So we need to go ahead and make a new file. So let's go ahead and say :E to go ahead and create a file. Currently we are in the init.lua, so we should be able to say // and then lua/config, and then we're going to go ahead and say keymaps.lua, hit enter, save just to make sure it writes. Sometimes, like I said, things are a little bit wonky. So now we're going to go ahead and set up a few keymaps, and to go ahead and do this, we're going to use a Lua call to a Vim function called keymap.set to go ahead and redefine any specific key sequences. These are also known as Vim motions. So we're going to go ahead and define some of the basic key mappings that we're going to use. Remember, these are the key mappings that I've been using personally. Go ahead and feel free to go ahead and experiment with your own or add more as you like, or discover new features that you want to access quickly. So we do need to do a few things. So the first thing we want to go ahead and do is we want to set our leader key to a specific binding. So to do that, we're going to use a couple of functions. So first off, we're going to go ahead and say vim.g.map leader. So it's going to go ahead and map the local leader. And then just to be safe, we're also going to go ahead and say vim.g.map local leader, which will also go ahead and map the leader key for our current buffer. And as you can see in our comment, anywhere where you see leader in the key mapping is going to specify the space key. So whenever we're going through and kind of setting key maps in the future, you're going to go ahead and see leader inside a bracket, such as basically means, hey, we're going to hit enter, and then we're going to go ahead and do the key map. So we're going to go ahead and set up some of our key maps. So first key map is going to go ahead to get rid of that annoying highlight search. So we didn't actually use the highlight search earlier, but I can go ahead and show you what it does in a second. So let's go ahead and add this. So as I mentioned, we're going to go ahead and use vim.keymap.set to go ahead and set the key map. And the way that we're going to set it is we're going to go ahead and pass in which mode that we want. So n is equal to normal mode, which basically means we're not in visual mode, we're not in insert mode. It's just a plain old normal mode that you start out in. And whenever we hit the escape key inside normal mode, it's going to go ahead and run the command no highlight search and then enter. And then we also went ahead and just added a little bit of description to know what this does. So just to kind of show you what this means by no highlight search. So if I go ahead and hit the star key, it's going to go ahead and highlight every instance of Vim. And there's no way to get rid of this. The only way to get rid of this is if you were to go ahead and say colon and then say no HL search and then hit enter, and then it'll go away. So this is exactly what our keymap's doing. So if I go ahead and say colon source and then % and go ahead and source this file, if I go ahead and say shift 8 to go ahead and highlight, now fingers crossed, if I set this up right, if I hit the escape key, except it's not working, it should be working. Maybe we just say source and then try it. There we go. So I just say source. So now, as you can see, you go ahead and do the star key, go and escape, it gets rid of it. So now you don't have to write out that entire sequence of characters there. So that one is a nice little handy to want to have. It took me a long time to try to figure out why the heck I couldn't get the search go away whenever I accidentally hit the star. So that's great. Next, we're going to go ahead and set up a really simple keymap to go ahead and exit the terminal mode, because it's also a massive pain to get out of the terminal mode. So once again, we're going to go ahead and use vim.keymap.set. And this one, of course, is going to be inside the terminal mode. So now if we hit escape, it's going to go ahead and run this key mapping, which I don't even know 100% what this is. It's like control/control-N to exit terminal mode. So if we go ahead and write this, and I'm not going to do this for all of these, but if we go ahead and source this and go ahead and hit term, it'll open up a terminal, which we probably shouldn't have done that. But now we're in terminal mode, and if we hit like we're going to be in insert mode in terminal, we can do things. And now it's like really hard to get out of this, right? So if we escape, it go ahead and gets us out of that. So that is really nice. Let's go ahead and go back into, although I messed up, because now we need to go ahead and CD into our Lua, CD back into config, and then go ahead and nvim our keymap.lua. I think I called it keymaps with an S. Yep, I forgot we turned off netrw, so now unfortunately we're gonna have to do it like that. But anyway, so that's the last one I'm going to show you. And then we can kind of see the other ones a little bit later on probably. And I might end up lying. I might show you the window navigation here. Next up, we're going to go ahead and set up some optional ones. So these ones are completely optional. These are like if you really want to practice your Vim motions. So this one is going to disable the arrow keys in normal mode, because in normal mode, you can go left with H, down with J, up with K, and right with L. So if you try to use your keys, it's a little bit less efficient because it's going to take your hand off the home row. So if you want to go ahead and practice using HK and L, so you can go ahead and enable this. Again, this is completely optional, up to you. I don't use it. I've gotten a little bit better at this point with using the H, L, K, and J keys, but it's up to you. Next up, we're going to go ahead and set up a lot better window navigation. So I'm going to go ahead and just copy these one by one. So first off, we're going to go ahead and vim.keymap.set in normal mode to control H. And this is going to go ahead and allow us to move over to the left window. This one's going to be similar to moving left in the regular old mode. Next, we're going to have vim.keymap.set in normal mode control L. So again, this is going to let us go to the right window, similar to how we do inside of normal mode, except with control. And then we're going to go ahead and have vim.keymap.set in normal mode, control J. This is going to go to the below window. And then finally, we can have vim.keymap.set in normal mode, control K, and this is going to go to the window above. So now this is cool and all, but we don't actually have, or we don't know how to actually create windows. So now I'm going to go ahead and set up some keymaps for doing just that, creating some windows more easily. So first off, let's go ahead and deal with vertical split. So we want to split it side by side vertically. We can go ahead and say leader or space WV. Remember what we said about the leader key? So anytime we see leader, it's going to mean space. So if we hit space WV, it's going to go ahead and split the window left and right. And if you remember in our config for our options, it's going to actually split it to the right. And then we're going to also have another one for splitting below. So this will be vim.keymap.set normal mode space WH. And this is going to go ahead and make a horizontal split where the window starts below because of that configuration we set up in the options file. So now we just have two more that are kind of like cool utility ones that are really nice. They're not as useful once you start getting to LSP LSPs and things, but maybe you just want to do this here and there, and that's going to be indenting. So this one's going to help us stay in indentation mode. This one's going to be a little bit hard to see without testing it, but basically what we're going to say is we're going to say vim.keymap.set in visual mode. If you do like the less than caret or the caret facing the left, it's going to go ahead and remap it to caret facing left GV. So what does this caret facing left do? So if you went ahead and tried to go into visual mode V, highlight this, and then you say shift and then the comma key, it's going to try to indent you, but it kind of took you out of the mode, which is not what we want. So if we go ahead and try to indent it again, so if we go ahead in visual mode and indent, then let me try, it's not actually working the way it should, which is interesting. It's because it's probably taking us out of visual mode. So if we go ahead and put the other one in as well, and we'll test it here in a second. And next we're going to go ahead and say vim.keymap.set, and we're going to go ahead and do it the other way to right indent. Oh, that's why it wasn't working, because I'm a silly goose and we need to actually indent the right way. So now let's go ahead and try this again. So we go ahead and grab this. So let's say we want to indent this line right here, and I say shift and go over, it takes us out of visual mode. So then if we want to go ahead and indent it again, we have to come back over here. We have to grab all this. We can find some other key maps to go ahead and make it faster, but then we can go ahead, that would take us out of visual mode. So whenever we're actually doing left and right indentations, of course, we do have the option to use some auto formats and stuff a little bit later on, but let's just say you just want to do one line. It'll be a lot nicer if you could just go ahead and stay in visual mode. So let's go ahead and W write this. Let's go and quit, and then let's go ahead and CD all the way back to our init.lua. So we're gonna go ahead and say nvim, init.lua, and then we need to go ahead and require this just like we required the option. So we'll go ahead and say require, and we'll say config and then .keymaps, and then go ahead and do this and W to save, and then let's go ahead and source, and %, hit enter. Now you're not going to see too much, and we already saw exiting terminal mode and the no highlight search, but we haven't actually seen like splitting windows and actually navigating through the windows. So like I said before, if we wanted to go ahead and split it down the middle of the screen vertically, we can say space WV, and as you can see, now we have two windows, and we can go ahead and navigate left and right with Control H and Control L. So if you watch closely on my cursor, at the end of those parentheses, you can see it moving back and forth. And now if I go ahead and say we want to split it down the middle, up and down or horizontally, we can say space WH, and now we have one on the bottom, and now we can go up and down with Control J, Control K. So now that goes up and down. If we want to close these, Control Q, Control Q, and there we go. Or I should say :Q, I'm sorry. Cool, so that's how we can go ahead and do that. And then of course we go into visual mode and highlight this, and then we go ahead and go to indent. So we say shift, and then this would be period. As you can see, it stays in. We can go back, forth, stays inside of visual mode. So that is great. So that is basically all of our basics covered at this point. So now we're kind of ready to move forward and start getting our plugin manager ready. So let's go ahead and hop into that next. As we mentioned at the beginning of the video, we're going to be going ahead and using Lazy as our package manager for this configuration. And it's pretty straightforward to set up and install plugins, and currently it's quite popular. Think of a plugin manager like npm or Maven for Node or Java respectively. Lazy will search for GitHub repositories contain the code for the plugins you want to install, clone them into a designated directory accessible to NeoVim, and then set them up for you. Plus, like I mentioned before, Lazy is simple to install and configure. So to go ahead and install Lazy, we're going to want to be inside of our init.lua file, which we already are. And first we're going to go ahead and create a variable inside Lua to store the path where Lazy and all the associated plugins will be installed. So we're going to go ahead and say local lazy path is equal to vim.fn standard path data, and then /lazy/lazy.nvim. So like we mentioned, this is going to basically declare where we want this stored. And then it's going to look for the standard data path, which is going to be basically .local/share/nvim/lazy or something like that. We'll take a look at that a little bit later, I believe, to make sure that Lazy gets installed properly, but it's going to be in a package similar to that inside your home directory. Next, we need to check to see if Lazy has already been cloned inside of the directory that we specified above. So to do that, we're going to go ahead and set up an if statement. So we're going to say if not, vim.uv or vim neovim.loop.fs_stat lazy path. Basically, all this is doing is seeing if the lazy repository has been cloned into our lazy path. If this has not been the case, then we want to go ahead and do a system call using vim.fn.system and passing in an object. Inside this object is going to be the different parts of the command that we want to run. So here we're going to go ahead and use git to clone. So we're also going to go ahead and say clone. We're going to use a filter to blob equal to none. And we're going to go ahead and clone this from the full key/lazy.nvim.get repository. We're going to go ahead and get the latest stable branch from this repository. And finally, we're going to go ahead and clone this to the lazy path. So basically, more or less what's going to happen, the first time that NeoVim opens back up, it's going to check to see if we have this repository in the lazy path. If it's not in the lazy path, what it's going to go ahead and do is going to clone it using all of these different properties or these different parameters. And then after that, it'll just be there from there on out. So now after this, we want to go ahead and put the lazy path on the Vim runtime path. That way it actually checks for this. So to do that, what we're going to go ahead and do is we're going to go ahead and say vim.opt.rtp, so runtime path, and we're going to go ahead and prepend the lazy path. So basically it's going to go ahead and look for the lazy repository on this path and then make sure everything's good. So I'm going to go ahead and W to go ahead and save this. Now before we actually go ahead and install lazy, I want to show you guys where this is going to be at. So I think for now I'm just going to go ahead and open up a new terminal tab. You guys can open up a new terminal as well. Now we're going to go ahead and then ls-a just so we can get a kind of lay of the land. And what we want to go ahead and do is we want to cd into .local. We'll go ahead and ls and we want to cd into share ls. So here we see an nvim. This got created for us whenever we installed nvim. We go ahead and cd into nvim and ls-a. You're going to see that all there is a netrw list or ish, whatever that says. There's no lazy path or anything here, but this is actually where it's going to be installed at. Now if we go back to our init.lua and we say wqa and then reopen it, it's going to be blank for a second because it's actually cloning that repository to that directory that we just opened up. So now to go ahead and prove that, we're going to go back into here and I'm going to go ahead and say ls-a again. And now you can see a directory called lazy. So this is going to basically store all the information about lazy for us. And now lazy is installed. But just because we have lazy installed on our system doesn't mean it's actually doing anything for us yet here in NeoVim. So we actually need to go ahead and configure lazy and to get everything working for us. So to do that, we're going to go ahead and declare a new Lua table that's called options to go ahead and hold some data for us. So to do that, we're going to go ahead and say local ops is equal to curly braces. And inside we're going to have a few different properties. So first off, we're going to have one called change detection. And we're going to go ahead and set our change detection equal to notify false. This is basically going to say, hey, don't notify us every single time a change is made to the configuration. If you go ahead and have this either not set whatsoever or notify equal to true, you're going to get a message down here in the lower bar basically saying, hey, there's been something changed. If you make a lot of changes, it kind of piles up and then it won't actually start NeoVim. It'll just kind of like sit there until you tab through all these different options. It's just really annoying. The next property is going to be called checker, and inside checker we're going to have a couple of properties. So first we're going to have enabled equal to true, and what this is going to tell NeoVim is going to say, hey, go ahead and go look for any updates to packages automatically for us. So then anytime we open up lazy, we can see if there's any package updates. However, we're also going to go ahead and set notify to false, and this is so that it doesn't spam us every single time there's a new update available. We can just go in and periodically check. So with that being said, now we can go ahead and actually set up lazy. So to do this, we're going to go ahead and require lazy from the lazy package and go ahead and call the setup function. So let's go ahead and see how we do that. So we're going to go ahead and say require lazy, and in Lua, this is going to go ahead and fetch that package for us. And then we're going to call the setup function. With NeoVim plugins, whenever you call setup, it's going to go ahead and run some configuration for you. And you can also pass in some different parameters that will basically configure the plugin for you. So lazy is technically just another NeoVim plugin that's going to be managing other plugins for us, so we can still call that setup function the same. So here we're going to be passing two different parameters to the setup function. The first one is just a string called plugins, and this is just going to tell lazy where all of the plugin specs are found. And by plugin specs, they're basically just Lua tables with different information about the plugin that we want installed. We're going to take a look at what the plugin spec looks like here in a little bit whenever we start installing plugins here after this section. And then the other one is that options, which is going to go ahead and pass in that change detection as well as that checker for us. So now we can go ahead and actually get lazy running. So if we go ahead and wqa you need to go ahead and close out NeoVim for this, and then go ahead and open up nvim init.lua again. It looks like there's an error. I'm not sure why. No specs. Okay, that's completely fine. We don't have anything inside of our plugins module right now, so it's going to complain a little bit. We're just going to ignore that. If we hit enter, you don't really see much happening. However, if you say colon and then lazy and hit enter, you're going to see this bright magenta screen, and this is because we do not have a color scheme installed yet, and this is just the default color of the pop-up or pop-up windows for NeoVim for some reason. We can see that we have one plugin, and it's called Lazy.nvim, or Lazy.nvim, excuse me, and we can also see that there's an update available, so we can actually go and update live. So if we go ahead and hold Shift U, it'll go through and start updating it. It went ahead and updated it. That's good to go. We can go ahead and colon Q, say lazy again, shield your eyes. Still says, now it says updated, I guess. I think we can probably say like sync it, and it's probably fine. It's already up to date, all good to go. So there's a couple other options here. So one, you see install. This is going to be like, for whatever reason, if you like restart or clear some stuff out and you don't have it installed, but your computer like sees it, or Nvim sees it in the path, you can go ahead and reinstall that. Update obviously does that. Sync will kind of get everything up to sync. Clean will go ahead and clear out any unused repositories, and then so on and so forth. I don't really know what check, log, restore do, but those are kind of the other options you have. Let's go ahead and colon Q, and now we are officially ready to get started on getting some actual plugins started. With that being said, let's go ahead and kick off and get into our plugins and have some fun here. So as we see, Lazy's default configuration here for color scheme is not the greatest, especially whenever you open up a pop-up window. It just absolutely blinds you. So let's go ahead and do our very first plugin, and let's go ahead and kick it off with the simplest plugin to configure, the color scheme. So I just want to go ahead and mention that there's countless color schemes available. Then each one's going to be subjective to the user's taste, but the installation process for each is going to more or less be the exact same. Currently, my favorite color scheme is called Dracula. However, if Dracula isn't your style, you can also search for other NeoVim color schemes online and then choose one that suits you best. Some popular ones include Capuchin, Tokyo Night, and Rosepine. And I'll go ahead and link a GitHub repository containing over 200 popular color schemes for you to browse. And then once you've made your choice, I'll go ahead and guide you through the installation process. To go ahead and install our color scheme, we're going to go ahead and say colon, once again, E, and we're going to go ahead and say /Lua to go to the Lua folder. This time I'm going to go into plugins, and we're going to make a file called color scheme.lua, and then we'll go ahead and hit enter to create that file. W just to make sure it writes properly, and we're good to go. So every single Lua script inside the plugins directory is going to need to return something called a spec. So the spec is basically just going to be a Lua table that we return out of these scripts, and it's going to have a few different things that are going to basically define that it's a spec. So first, let's go ahead and return a Lua table out of this. And inside the Lua table, we need a couple things. The first thing we need is a shortened GitHub URL for whatever plugin that we are installing. So let me go ahead and paste in the shortened GitHub URL for Dracula. So here it is, motif/Dracula.nvim. Then sometimes we're going to go ahead and add a property called lazy. So lazy is basically going to define whether or not this plugin is going to be loaded immediately or if it's going to be waited on. So here we want this plugin to load immediately because we don't want to see the default color scheme. So here we're going to go ahead and set lazy equal to false to make it load immediately. And then specifically for our color scheme, we're going to have another property called priority in here. We're going to go ahead and set priority equal to 1000. And this is more or less going to go ahead and get this to load up first. If it doesn't load up first, it's going to load up dang near first. That way we have to spend as little time as possible looking at the color scheme that we don't want to see, and we can actually see the color scheme that we want. And now the final step in setting up most NeoVim plugin configuration is going to be defining a configuration function. And then this is going to allow us to set any special options, go ahead and create any keymaps, and even call the specific plugin setup function with any other configuration that we want. So to do this, we're going to go ahead and make a property called config and set it equal to a function. And inside of this config function, we only need to do one thing. So we want to make sure that we set the actual global color scheme of our NeoVim configuration to the color scheme that we want. So to do this, we're going to go ahead and call vim.command.color scheme and then set it to whatever color scheme that we want. So here in our case, obviously I want it to be Dracula. If you guys like to use Dracula after I show you the color scheme, you can go and keep it Dracula, or you guys can go ahead and just look for whatever color scheme that you like as well. So to do this, we're going to go ahead and say WQA to go ahead and save and quit everything. And then if we go ahead and go into our nvim init.lua and open it back up, you're going to go ahead and see that lazy started up and it installed Dracula.nvim, and you can see all around here that the color scheme has changed. Now there could be some better minor things here. Like for example, it's kind of hard to see the pop-up. It doesn't really stick out much. So there's probably some stuff that you can actually modify here. But as I mentioned, we're going to go ahead and keep this as simple as possible. So I just want to show you guys how to install this, and then you guys can kind of go through the color scheme plugins like configuration on GitHub and kind of set things up yourself, because I've definitely at one point or another kind of tweaked Dracula a little bit to make it look a little bit better, have some transparencies, things like that. But I want this to be a starting point, so I'm not going to give you guys some hyper specific color scheme stuff whenever you guys might not even like the color scheme whatsoever. So let's go ahead and close out of Lazy. Now we're good to go ahead and start installing our next plugin that'll go ahead and help us in creating files much simpler. Now doing this is our next choice of a plugin to install might be a little bit controversial, as some may see this plugin as unnecessary. However, it's very familiar to many Java developers, and it also aids in file navigation and file creation during our configuration steps here. The next plugin that we're going to be configuring is called Nvim Tree, and it's going to go ahead and replace the netrw plugin that we encountered earlier with a lot more user-friendly file tree, as well as easier ways to go ahead and create files on that file tree. So to install this plugin, we're going to follow the same steps as our color scheme. So first, let's go ahead and create a new file. So we'll go ahead and say :e, and we're in the init.lua, so we're going to say ./lua/plugins, because we want it in our plugin specs. And we're going to say nvim-tree.lua, hit enter, :w just to be safe to make sure it actually loaded, and we're good to go. So now, like we did previously, we're going to go ahead and create a Lua table to return. So we're going to go ahead and say return curly braces, and then inside of our Lua table, we're going to go ahead and bring in the shortened GitHub URL for Nvim Tree, which is nvim-tree-nvimtree.lua. Next, all we need to go ahead and do is we just need to set up the config function. So we'll go ahead and say config is equal to a function, and then inside of our config function, we got a couple things to set up. So first off, we want to go ahead and set up a keymap to be able to open and close the file tree explorer, because sometimes, or a lot of time, we won't want to open. Maybe we just want to go ahead and create a file, close out of it, and we're also going to have a lot better means of looking and searching for files a little bit later on. So it's just going to basically be in the way. The reason I like it here is because I like being able to just hit one single key to create a file. So to go ahead and create the keymap, we're going to do the same thing we did inside of our keymaps. We're going to say vim.keymap.set. This is going to be in normal mode, and what this is going to go ahead and do is it's going to say leader E, and then this is going to run the command nvim tree toggle, and then this is going to hit the enter key. So basically what this will do is it'll open and close our Nvim tree. Next, we want to go ahead and call the setup function. So first we need to get access to the setup function. To do that, we're going to go ahead and say require Nvim tree, and then we want to go ahead and call .setup with a table inside of it. So inside this table, we're going to go ahead and pass in a couple options. The first thing we want to go ahead and do is say hijack netrw. Hijack netrw will basically allow us to go ahead and use Nvim tree in place of netrw. Just going to hijack it. And then next we want to also go ahead and set auto reload on write equal to true. This is going to basically say anytime that we write inside of that directory structure, it's going to go ahead and rewrite the file tree. This is going to be really useful a little bit later on whenever we get into our Java related dependencies and we're going through and creating brand new files and stuff inside of our Java application. And we want to go ahead and rerun or reload that tree that we can actually see it. So let's go in w here. And now this is all we have to do to install it. So we can go ahead and say :wqa to go ahead and close that. We can go ahead and say nvim init, and it's going to open up Lazy as it did before, and it's going to install it. So now that it's installed by Lazy, we can say :q, and now if we say space E, you can see that it opens up a file explorer on the left side. And we space E again, it will close it. So now we can just open and close the file explorer, and we can go ahead and open up and see our different files and whatnot. So this looks great. So now this is the coolest part about this is now instead of saying :E to go ahead and edit and create files, if we wanted to create a new file inside of our plugin, we can just say A, and it will actually create a file for us. If we wanted to rename it, we can say R, it'll rename it. If we want to delete it, we can say D, it'll delete it. So we can actually do a lot with this file tree, a lot easier than trying to type out all of those commands. Of course, you probably could have just mapped :E to a different command or whatever, but this is just a lot nicer. Cool. So again, this one, a lot of people don't find as necessary because with the next plugin that we're going to install, you don't even actually need a file explorer. You can just easily find files with this file finder. But what I like about this is now we can just create files easily. And if we ever do just want to see what the structure looks like, that's good to go as well. So let's go ahead and move forward and get into our next plugin here. Let's go ahead and start out by making a new file in our plugins by hitting A inside of our file explorer. And then we're going to say telescope Lua. Go ahead and hit enter and it'll open it up. Go ahead and hit space E to go and get rid of that. And now let's go ahead and talk about Telescope. So Telescope is a highly extendable fuzzy finder, enabling us to search for files, text, and more throughout our working folders. With Telescope, navigating files becomes much faster than sifting through a hierarchy in a file explorer, and this plugin is going to be installed similarly to all of our other ones. However, now we're going to start seeing a little bit more complex setups. Again, it's all going to be kind of the same. We're just going to do a little bit more code inside of our config function. So as previously, we're going to go ahead and return our Lua table, and then inside of our Lua table, we're going to go ahead and pass in the shortened GitHub URL for Telescope. Next, we're also going to go ahead and pull a specific version of the plugin. So to do this, we're going to go ahead and say tag is equal to 0.1.6. This is just the specified tag that they put in their own configuration. You guys can go ahead and explore this. Next, we're going to go ahead and introduce a new property inside of this table that we've been returning. This is going to be called dependencies, and dependencies will be equal to another Lua table. Inside of our dependencies property is going to be a list of other plugins that we want to make sure installed before we actually install the plugin that we are installing now. So kind of like in Java, we have different dependencies. We want to make sure they're installed before we run our project. This is going to be the same thing. So here we're going to want to install something called Plenary. So similarly to above, we're going to go ahead and pass in the shortened GitHub URL for Plenary. And Plenary is just a general purpose plugin that helps users build user interfaces and other things inside NeoVim plugins. So it's just nice to have that way. It kind of enhances the experience of other plugins. Now we got all of that set up. Let's go ahead and create our config function. And inside of our config function, we're going to go ahead and set up a few things. Primarily going to be setting up keymaps. So the first thing I want to go ahead and do is we want to get access to the built-in functions of Telescope. So to do that, we're going to go ahead and say local built-in is equal to require telescope.built-in, and that's going to go ahead and get us all of those functions and store them inside that built-in variable. Now we're going to go ahead and set up our Vim keymaps the way that we have been doing. So first, we're going to go ahead and set up a keymap that allows us to search for files by their names. So once again, we're going to do that by saying vim.keymap.set. This is going to be in normal mode. And we're going to set this to space FF, and this is going to allow us to find files by their names. Next, we're going to go ahead and set a keymap. We're looking for the text inside of files. Once again, to do this, we'll say vim.keymap.set, and we're going to go ahead and set this in normal mode to space FG, and this is going to use livegrep to find by grep. This livegrep is what's going to be using that ripgrep utility that we installed earlier to go ahead and find things a lot faster and easier for us. Next, we're going to go ahead and set up a keymap that allows us to kind of search through different code issues. So this one is going to be vim.keymap.set. We're going to go ahead and set this one to FD or space FD for find diagnostics, and this is going to use the built-in .diagnostics function. Next, we're going to set up a keymap for resuming the previous search that we were just in. Once again, we'll say vim.keymap.set, and this is going to be in normal mode, and this is going to be space FR, so find or resume, and this is going to use that built-in function .resume. Next, we're going to go ahead and search for recent files that we've looked at. So here we'll say vim.keymap.set normal mode space F dot, and this is going to call the built-in .old files function, and this is going to find recent files that we opened up previously. And then finally, we're going to go ahead and search for the buffers we have open. To do this, once again, we'll say vim.keymap.set in normal mode, and then this is going to be FB, and this is going to use the built-in function called built-in.buffers to find existing buffers. Now this is all good and great. However, we actually want to install two different dependencies or two different plugins in this single table. What we can do to this, we can go and just wrap all this inside of another table, and then we can just create a whole other table to make our next dependency or plugin, whatever you want to call it. So let's go ahead and use our little trick here. So let's go ahead and highlight all of this, and then let's go ahead and say shift period to go ahead and shift that all over. And then we're going to go ahead and install a UI library for our Nvim Telescope just to make things look a little bit better. So to do that, we're going to go ahead and bring in a shortened GitHub URL for a Nvim Telescope UI select. And then we're just going to go ahead and set up our config. So let's go ahead and say config is equal to a function. And then inside of our config, we need to set up a couple things. First off, we want to go ahead and get access to the actions on Telescope to kind of be able to tell it how we want to move around. So to do that, we're going to go ahead and say local actions is equal to require telescope.actions, and this is going to go ahead and get us access to those navigation functions. Next, we want to go ahead and call a telescope setup function to go ahead and set up all these different UI options. So to do that, we're going to go ahead and require telescope and then call the .setup function with a table inside of it. So we're going to set up a few different properties here. First, we want to go ahead and use UI select as our drop-down UI. So to do that, we're going to go ahead and make a property called extensions, and inside extensions, we're going to have a property called UI UI select equal to another table. Inside of here, we're going to go ahead and require telescope.themes, and we're going to go ahead and call the .get dropdown function. This is basically telling Telescope that we want to go ahead and use the UI select dropdown menu as our UI. Next, we want to go ahead and set up the key mappings for our Telescope. That way we can actually go around and select different parts and choose which file that we want to go into. So to do this, we're going to go ahead and make a new property called mappings instead of equal to a Lua table. And inside of mappings, we're going to go ahead and say I is equal to a new table. And this is basically just going to be an insert mode. So whenever we're typing into the text box, these are what the key maps are going to be. First, we're going to go ahead and set up Control N to cycle through the history of files. So this is basically just going to toggle up and down, or in this case, it's going to toggle going downwards in the main list of files. Then we're going to go ahead and set Control P to cycle previous. So this is going to go ahead and cycle upwards through all of the different files that we have found. Next, we're going to say Control J will move to the next selection. So basically, I haven't fully gotten this to work. I'm pretty sure this has something to do with like code actions and whatnot, and I haven't tested out with any code diagnostics. But basically, you can go ahead and go up or down to the next preview, and if we say Control K, we can go ahead and go up from the previous preview. That's all the mappings that we need. Primarily going to be using N and P, and then if I ever find a real reason for using these, I'll go ahead and update the video or in the description or something. But this is kind of for like preview stuff. I haven't used it much, but it also could be because I just haven't used Vim all as much. I kind of basically just got my configuration all working and wanted to share it with you guys. So there's still one more thing that we want to go ahead and do. We need to actually load the UI. So to do that, we're going to go ahead and call required telescope.load extension, and we're going to go ahead and load the UI select extension to go ahead and load in this plugin. So that's basically everything we need to do to set up our Telescope and give Telescope a pretty UI to actually view things. So let's go ahead and WQA to save and close everything. If we go ahead and open Nvim and Knit once again, you're going to see that it's installing everything. So it installed Planary, it installed Telescope, and it installed Telescope UI select. So if we go ahead and colon Q, now since we are in the root directory, it's going to be able to find all the files. But if you're inside of like a specific directory, it's only going to find the files in that specific directory. So it's not going to like find all the files on our computer here. But we can go ahead and just take a look at some of our key mappings. So if we go ahead and say space FF, you can see that we are in our find files. If we go ahead and say Control P, it goes up the list. Control N, it goes down the list. So let's say that we want to go ahead and find our color scheme. So we can just say color scheme. You can see that there. If we go ahead and hit enter, it'll go ahead and take us to color scheme. Cool. If we want to go ahead and search by specific text, we can go ahead and space FG to grep. And let's say they want to go ahead and find where we set Keymaps. We can say Keymap. And now we can go ahead and go through all the different files that we have Keymap in, right? So we can go ahead and view all of those different Keymaps. Let's say that we want to go ahead and, whoops, I broke it. There we go. Let's say that we want to go to our actual like Keymaps file. So we have our config Keymaps. Hit enter. There we go. We can see all of our Keymaps. That's great. If we say FD, we don't have any diagnostics right now because we don't have an LSP telling Vim we have any diagnostics right now. So this one I'll have to kind of circle back to. So now if we go ahead and say space FR, it'll go ahead and resume that last script that we were doing. Even pulled up the key map. Okay, that's cool. If we go ahead and say space F dot, it'll go ahead and show us some of our old files that we had open, which is great. And then finally, if we go ahead and say space FB, it'll show us our open buffers. So right now we have Keymaps open, we have color scheme open, and we have a knit.lua open. If we go ahead and say WQA, shouldn't write anything, but just go ahead and open this up. We go ahead and say space FB. Now we only see a knit.lua open because we went ahead and closed out of all of our buffers. So this is really powerful because you can go ahead and just search for whatever you want and instantly find it. And this doesn't even stop here. You can also go ahead and continue extending this. There's a ton more you can do with Telescope. So once you become more familiar with NeoVim, I highly recommend looking into the Telescope docs and then leveraging the power that it provides. But now that Telescope's installed, let's move on to more code related plugins. And now this is where things are really going to start turning into more of an IDE. So moving forward, we're going to go ahead and start getting some nice syntax highlighting here. So let's go ahead and space E to open up the file explorer, and then let's go into our plugins directory and hit the A key. And let's go ahead and make a new file called treesitter.lua. let's go ahead and go into treesitter.lua, and let's go ahead and kind of talk about what Treesitter is and then start getting this set up. So Treesitter is a plugin used to beautify your code inside of NeoVim. It reads the extension and contents of the file and then determines the language that you're writing in. And if you have the current language processor installed for Treesitter, it'll go ahead and parse through your code and then highlight different symbols such as function, keyword, and Lua, string literals, method parameters, and more. Overall, it improves the development experience. So let's go ahead and get this configured. So as always, we're going to go ahead and return a Lua table. And inside the Lua table, the first thing we need to do is go ahead and include that shortened GitHub URL. For this, we are going to go ahead and include one dependency. So we'll go ahead and say dependencies is equal to an empty Lua table. And inside the dependencies table, we're going to go ahead and pass in the shortened GitHub URL for nvim ts auto tag. So ts auto tag is a plugin that's going to utilize Treesitter to go ahead and read through our code and understand the structure to automatically close tsx tags for us, because straight up LSPs aren't smart to do that, and the auto pairs that we're doing later is also not going to be smart to do that, because we need the power of Treesitter to kind of know how things are working. That's good to go. Next, we need to go ahead and set up a new property that we haven't seen yet. So this is going to be called build, and we're going to go ahead and set this up to run a command called ts update whenever we go ahead and start up our plugin. This is basically going to make sure that all of the servers that we want installed are installed and updated and ready to go for us. That way it highlights our code successfully. So now that we have all of that set up, let's go ahead and set up our config function. And inside of our config function, we're going to go ahead and just do some simple things. First off, we're going to go ahead and gain access to tsconfig's config function. To do that, we're going to go ahead and say local tsconfig is equal to require nvim treesitter.config. So this is going to allow us to basically call the setup function, and that's exactly what I want to do next. So let's go ahead and call the tsconfig.setup function, and inside, like always, we're going to go ahead and pass some different parameters. So the first thing that we want to do is we want to make sure that we have all of our different language servers installed. Here we're going to make sure that Vim, Vimdoc, Lua, Java, JavaScript, TypeScript, HTML, CSS, JSON, TSX, Markdown, Inline, and Git Ignore are all installed. It's very important that you have Vimdoc installed, otherwise you won't be able to view the help docs for some reason. I don't know why I made the decision, but to do this, we're going to basically say ensure installed is equal to a list with all these different servers. So ensure installed with Vim, Vimdoc, Lua, so on and so forth. And this is going to make sure that these servers, or whatever we want to call them, these programs to highlight our code for us, are installed. And then we want to actually make sure that we enable the highlighting. So to do that, we're going to set another property of highlight is equal to enable true. And then we also need to go ahead and enable the auto closing of tags in TSX. So to do that, we're going to go ahead and make one more property called auto tag and set enabled equal to true. That's as simple as that. We can go ahead and W to save that. We can go ahead and WQA. Again, not necessary to save it again. It is what it is. But now if we go ahead and nvim init, it's going to go ahead and install our Treesitter and our Treesitter auto. Let's see something wrong with this. Sometimes this pops up. I'm just going to ignore it. And we can also go ahead and just double check that and see what we did wrong. But you can see that installed things. And now this looks a lot better, more vivid colors. And it's going to be utilizing that term GUI color that we saw earlier. So let's go ahead and open up our file explorer and let's just see what our issue was here with Treesitter. So it said that there's an issue with buff read something, and it could just be nothing. Sometimes lazy is just a little bit finicky. So if we go ahead and WQA, let's just see if there's still an issue. Yeah, so it's just lazy being kind of silly. So don't be worried if you see some of that. Sometimes whenever things are installing, some things just might be not working properly or something else. So this is going to go ahead and make everything just look prettier and pop, and it's going to go ahead and, like I said, utilize more of those colors to go ahead and more or less highlight the key things inside of our code. So now that we have the highlighting and things looking a lot better so we can kind of see what's going on inside of our code, let's go ahead and get down and dirty and go ahead and start getting some real feedback about our language from NeoVim. So these next couple of sections are going to be the most lengthy sections because they're going to get into our LSPs, or language server protocols, which was originally developed by Microsoft specifically for VS Code, and then they decided it was too good to just kind of keep inside VS Code, so now they let it be open source. So basically an LSP is an actual server application that's going to be running on your computer, and then NeoVim has a direct contact with that to go ahead and tell you if there's anything wrong with your code, give you suggestions and some things like that if there's anything wrong with your code. Now, of course, I'm not an expert in LSPs, so if you do want to learn more about LSPs, I will go ahead and link a video down in the description below that really goes in depth with LSPs by TJ DeVries. He's really good about it, and he even developed some LSPs himself for some other languages that didn't have anything or just need a little bit more support. So again, I'm not an expert expert, but I'm going to go ahead and show you guys how to set up all the different LSPs that we're going to need for Java full stack development. So we're going to go ahead and open up our file explorer, and let's go ahead and go to our plugins directory, hit A, and we're going to go ahead and call this lsp-config.lua. Let's go ahead and go into our LSP config and close out of our file explorer. To fully configure our language server protocols, we're actually going to need 5 different plugins. And since all of these plugins are related to setting up our LSPs, we're going to go ahead and organize them into a single Lua table and then return them here from our LSP config file. So the first plugin that we need to configure is called Mason, and Mason is a binary manager. Essentially, Mason will download and install all the LSP servers for us in a central location that NeoVim can easily find. This is going to go ahead and simplify setting up our LSPs a lot because we don't have to manually go and find and download all the different binaries for the servers ourselves. So let's go ahead and install Mason. So let's first go ahead and return our Lua table, and inside of our Lua table we're going to set up another Lua table where we're going to go ahead and put the shortened GitHub URL for Mason. And then all we need to do after this is go ahead and set up the config function, and inside the config function we want to go ahead and require Mason and call the setup function from Mason. So that's all we need to do to get Mason configured. Next up, we need a plugin called Mason LSP Config, and this is a complementing plugin to Mason, which is going to ensure that any specified LSP servers that we want installed are installed automatically. While it's not difficult to install an LSP manually yourself using the Mason UI, this is a lot more convenient just to make sure everything is going to be installed and everything's working fine. But I will go ahead and show you how to install specific ones later on, just so you can see how to do it in case you ever run into a one-off where you need to go ahead and go install it. So as always, let's go ahead and set up our table. And then inside the table, let's go ahead and bring in the shortened GitHub URL for Mason LSP config. And then all we need to go ahead and do is set up a config function once again. And then inside of our config function, we want to go ahead and require Mason LSP config. We want to call the setup function with a table. Inside the setup function, we want to just make sure that we have all of the different servers that we want installed automatically. To that, we're going to go ahead and say ensure installed is equal to a list of servers. And this list of servers is going to include Lua LS, which is a Lua language server, which is going to allow us and help us out in configuring the rest of our configuration. We want TS server, which is going to be the TypeScript/JavaScript server, and we want JDTLS, which is the Java language server. That's good for that. Next, we want another Mason related plugin, and this is going to be called Mason Nvim DAP. And Mason Nvim DAP is going to go ahead and utilize Mason similarly to how Mason LSP Config utilizes Mason, but this one is going to ensure that debug adapters are installed properly. So basically, for whatever reason, Mason LSP Config refuses to install debug adapters. Debug adapters are basically tools that allow us to actually debug code such as Java code. So we need to make sure those are installed similar to our LSP config. So let's go ahead and just set up a table here to go ahead and install this plugin. And let's go ahead and bring in the shortened GitHub URL for Mason Nvim DAP. And then below there, let's go ahead and set up our config function. And inside of our config function, we're once again wanting to ensure that our Java debug adapter is installed. So to do that, we're going to go ahead and require Mason Nvim DAP. We're going to go ahead and call the setup function with a table in it, similar to above. And once again, we're going to ensure installed, and this is going to equal to Java debug adapter. And I'm going to try out Java test because the LSP config won't install test. I don't know if the Nvim DAP will, so we're going to find out here really quickly in a second. If it doesn't install with the Nvim DAP, go ahead and just delete this right here, and I'll show you guys how to install it manually. No big deal. Cool. So now we just have a couple more things to install. Next, we need to actually get the Nvim JDTLS plugin, which is going to be a utility plugin for helping us configure the Java language server. And this is going to be split up a little bit weird, and the Java language server is going to be the most complicated part. But here, all we're going to go and do is get the actual plugin. We're going to set up the plugin in a configuration file, and we'll get into that a little bit more in depth a little bit later on. But just kind of know that's what we're doing here. Let's go ahead and try to get the plugin installed for our Nvim JDTLS. So again, we're going to go ahead and have a table, and inside the table, let's go ahead and bring in the shortened GitHub URL. And all we're going to do here is we're going to have a dependency array, and inside the dependencies, we're going to go ahead and bring in the dependency for Nvim DAP. So like I said, we're not going to configure it here. We're just going to go ahead and make sure that Nvim JDTLS is installed with our LSP stuff. We're also going to make sure the Nvim DAP, which is kind of like the debug adapter plugin for NeoVim, is also going to be installed, because whenever we actually set up Nvim JDTLS, we need to make sure sure that our Nvim DAP is installed. That way we can actually debug things. We're almost done with the LSP configuration. We just need to actually set up the LSP config, which will go through and set up all of our actual configurations for our LSPs. So let's go ahead and set up one last Lua table. And inside of our Lua table, let's go ahead and bring in the shortened GitHub URL for LSP config. Let's go ahead and set up our config function once again. And now we can go ahead and start setting up the configurations for our different LSP servers. So the first thing that we need to go ahead and do is get access to the LSP config plugins, different functions. So to do that, we're going to do something that we've done similar. So we're going to go ahead and say local LSP config is equal to require LSP config. Next, we're going to go ahead and set up the different language servers. For the time being, we're not going to do anything special with them. Keep in mind that you can go through and kind of really customize different aspects of the LSP servers, but the thing that we're really focusing on here is the Java side things. So we're going to keep the other two language servers pretty lean for the time being. You can kind of go through and learn more about them a little bit later on. So first, let's go ahead and set up the Lua language server. To do that, we're going to go ahead and say lsp config.luals.setup. For now, we're just going to call the function. We're not going to pass anything into it. Later on, we'll get a little bit more in depth with this. Let's go ahead and also set up the TypeScript language server. We're going to do the same exact thing, what we call lsp config.tsserver.setup, and we're just going to call the function. So this will set up and start up the language server whenever we go ahead and attach to a specific file. So that's good to go. And now let's go ahead and set up different keymaps that are specific for finding different things in code, navigating through code, things like that. So the first one's going to be for documentation to show us different documentation about code. So to do this, we're going to say vim.keymap.set inside normal mode, and we're going to go ahead and say leader ch or space c+h, and this is going to go ahead and show code documentation on hover. So this will call the vim-lsp.buff hover. As you can see by the description, it's going to have a little pop-up window with documentation when it's available. Now, some different things, like for example, if you're writing your own code and you hover over a method that you wrote, if you don't provide Java doc for it, it's probably not going to show you documentation, but more well-known Java libraries and whatnot will most likely still have this. Next, we're going to go ahead and set up a keymap for going to where a method or function or a variable was defined inside of your code. So to do this, we're going to go ahead and say vim.keymapset in normal mode, and this one is going to be space c+d. And again, like I said, this is going to go to where something was defined, so like your variable, your method, whatever. Next up, let's go ahead and set up a keymap for displaying the different code actions that we could take on a diagnostic. To this, we'll say vim.keymap.set, and then this is going to be in normal mode and in visual mode for space plus c plus a. So more or less what a code action is going to do, for example, if you're trying to import something or you have an issue like a warning, if you go ahead and hit space ca, it's going to give you a bunch of options for what you might want to do to go ahead and fix that issue. Next, let's go ahead and set one up to view all the references to a method or variable. So to do this, we're going to say vim.keymap.set in normal mode. This is going to be space plus c plus r, and this is again going to go ahead and display any references to the code that's under the cursor. Next, let's go ahead and set up a keymap to go ahead and show all the implementations for the code under the cursor. So this would be, for example, if you have a interface in Java and you have different implementations of the interface, this will go ahead and show you all those implementations. So to do this, once again, we'll use our vim.keymap.set function, and this is going to be in normal mode to space plus c plus I, and this is going to go ahead and go to all the implementations, or basically show you all the implementations of this interface if you're talking about Java. Next, we'll go ahead and set up a keymap to allow us to smartly rename things that is under the cursor. To do this, we'll say vim.keymap.set in normal mode, and this is going to be to space shift R, just because you might not use this as much. So for go to reference is probably going to be used more often, so that's why I went ahead and did uppercase R for this, which would be shift R like I mentioned, and this will go ahead and call that vim-lsp buff rename, and this is going to go ahead and basically do like a smart rename that you'd see in IntelliJ. And finally, let's go ahead and set up one more keymap to go to a declaration. So to do this, we'll say vim.keymap.set in normal mode, and this is going to be leader shift D. Again, more likely you're going to go to find a definition rather than find declaration, and in this case, a declaration is going to be like, where is this class declared? So for example, like an interface, where's the interface declared, things like that. So let's go ahead and W. Now, assuming I didn't screw anything up, which there is a high possibility that I probably screwed something up here. There's a lot more code than we've seen previously, but let's go ahead and say WQA to go ahead and close out of this. Let's go ahead and say nvim init.lua, and let's just pray that all of this installs properly. We do have an issue with user_config, so we can go ahead and see what the issue is there. And where is this at? In Mason LSP LSP config, attempted to index user config. I might have just typed something wrong. So let's go ahead and close out this. And then let's go ahead and let's go space E, and I should actually be doing this. So space FF, and let's go ahead and find, this is LSP config, hit enter. So this was over here. Actually, I don't know what that was. LSP config setup. Let's go ahead and try this. I think we might need to add these. WQA, let's see if we still get the error. Okay, I do not see the error, and our LSP is actually working. There we go. So I did actually need to do that. So we face space FF. Let's go back into LSP config. There we go. And we can see now on the left side, we have these issues. So these are those diagnostics. So now if we space FD for diagnostics, you can see all the different diagnostics that we have. So these are all warnings because it doesn't know what Vim stands for. So we can say space CA for code action. And we can actually go ahead and just say, hey, Vim is a global, and we don't want this to like basically complain. And I don't know like what the difference in these two is. It looks like the same, and it might just be redoing the same thing. We'll go ahead and say that, and like, whoops, I meant to say W, but now it's not complaining because we went ahead and marked all the instances of Vim in here to go ahead and basically be a global variable. So if we go ahead and space, whoops, space FF, go ahead and find files, LSP config, whoops, if I could type LSP config again, that's good to go. All these are fine. Now, right now, Java's not going to actually be working. We'll have the JDTLS server, and if we wanted to, we could have ran lsp.jdtls.setup, and it would have started the server for us, but we want to do a little bit something more special. And I also still want to go ahead and show you guys, if you do need to go ahead and install something with Mason, how to do that. So we go ahead and say colon, and then Mason, hit enter, and it doesn't look like it actually installed the Java test, and it actually didn't install the Java debug, which is interesting because I'm pretty sure this worked before. So I guess the debug, I might have broken something here. Maybe we just ignore this and don't put it in. Again, I was just kind of experimenting with this, and it doesn't seem like it's working, but I can go ahead and show you guys how to do this. So colon Mason, and we can go ahead and search. I don't know if it's just Command F, Control F. Yep, and we go ahead and just look for Java because that's what we want. And here we have Google Java format, which I am going to go ahead and install just to be safe. It might install it manually for us whenever we set up Nvim JDTLS, but to go ahead and install it, we can go ahead and just hit I, install that. We also want the debug adapter, so I can go ahead and hit I above the debug adapter. We also want Java test, so hit I over that. Now those are installed. If we go ahead and clear that, you can just kind of go through and see the different LSPs. So there's a whole bunch of LSPs here, basically for everything. There's also like linters and formatters and stuff like that. You can do a whole bunch of stuff with this. So that is Mason. That is how we can set up like our basic LSPs. But now the actual part that I'm making this video for is setting up the Java LSP. So let's go ahead and get into that. And it's going to be the most complicated part. So please buckle in. Now that we've got all of our LSP stuff set up, let's get down and dirty and get into the actual hard part, which is getting Java fully working. And there are a couple of caveats here or there that I go ahead and point out, but let's go ahead and get into it. Let's go ahead and space E to go and open this up. This is going to go into our config because this is not actually like a plugin. This is just configuring the plugin. It's kind of confusing, but the reason that's going to be in here is because we don't want this to load every single time the application loads up. We're only going to want this to load up one time on a specific event. So that's why it's going to go into plugins. So let's go into space A, and we're going to go ahead and call this JDTLS. Lua. Let's go into JDTLS.lua and then hit space E. So again, I just want to mention that this is going to be the most complicated part. This is going to be the most code. It's like 200 something lines if you take out comments. It's almost 300 with comments, but the comments are nice because it's going to go ahead and tell you what's going on. All of this code is inside the GitHub repository, so if you get lost, you can go ahead and go take a look, get everything working, but that's where we're going to be at. We're going to go ahead and set up like a few helper functions first, including ones for setting keymaps, stuff to set up debugging, as well as kind of getting where all the different files are and everything like that. And then we'll actually go through and actually set up the plugin itself and get it running. The first thing we need to go ahead and do is we need to start and create a helper function, and this is going to be called get JDTLS, and this is basically going to get information about all the different packages that we need and where to find them. That way, whenever NeoVim goes to start JDTLS to server, it knows exactly how to do that and where to find it. So the first thing we want to go ahead and do is we want to get the Mason registry, and we want to do that by saying local Mason registry is equal to require Mason-registry. Now this is going to be part of that Mason plugin, and basically this is going to allow us to gain access to where all those downloaded binaries are. After after we get this, we want to get the specific JDTLS package, which is our specific language server. And to do that, we're going to go ahead and say local JDTLS is equal to mason registry.get package. Now this mason registry.get package, JDTLS, is going to go ahead and store all the different information, including where at on the actual file system, our JDTLS plugin, and all the files are located. And that's going to help us out here. So next we want to go ahead and get the actual path where JDTLS is installed with Mason. So to do this, we're going to go ahead and say local JDTLS path is equal to JDTLS.get install path. And basically this is going to actually go into our file system and find where this is installed at. And I can actually kind of show you guys where this is at here in a second as well. So next we want to actually get access to the jar itself that runs the language server. So to go ahead and do that, we're going to go ahead and say local launcher is equal to vim.fm.glob, and it's going to go ahead and take our JDTLS path and concatenate it with plugins/org eclipse equinox launcher.star.jar. So it's going to find any version of this jar that is inside of our plugins inside of JDTLS. So this is going to specifically go to where Mason installed our JDTLS, go into the directory for plugins and get the launcher, and this is going to run our server for us. Next, we want to go ahead and declare what operating system we're using. That way it can load in specific plugins. So to do that, we're going to go ahead and say local system is equal to Linux. If you're using Windows for some reason, go ahead and put Win here. If you're using Mac, go ahead and put Mac there. And I went ahead and typoed right there. So that's no bueno. But there we go. So now we have our operating system. And then we want to go ahead and get the actual configuration files for our specific operating system. So to do that, we're going to go ahead and make a variable called config. We're going to set this equal to JDTLS path. And we're going to concatenate /config. We're also going to go ahead and concatenate the system. So again, this will make more sense in a second when I go ahead and take you to the directory this is looking at. Basically, this is going to be like, okay, the path to where it's installed /config _ whatever our OS is. Finally, we want to go ahead and obtain the path to our Lombok jar. So to go ahead and do that, we'll go ahead and say local Lombok is equal to JDTLS path and then concatenate Lombok. So now that we have our launcher, so the server itself, where our config files are and where the Lombok jar is for all of this, we want to go ahead and return the launcher, the configuration, as well as Lombok. That way we can use it later on inside of our setup function. I'm going to go ahead and save that. And now let's go ahead and go back into the tab up here. And let me go ahead, and it might be in here. I don't remember 100%. So if we ls-a, you can see we have Mason. So let's go ahead and cd into Mason and ls. Now you can see our packages. So if you go ahead and go back in here, you see that we have /plugins. So maybe we need to go one more. So let's go ahead and go cd into packages. We ls in here. Now we can see our different packages. So now if we go ahead and cd into JDTLS, cd JDTLS, ls, and now you should start seeing some stuff. So remember, we went ahead and looked at plugins. So if we come back in here, we have this JDTLS /plugins /org eclipse equinox launcher. So we go ahead and cd into plugins. In ls, you're going to go ahead and see a whole bunch of stuff here. If we go ahead and look for the Eclipse Equinox, so let's see, Equinox app, Equinox launcher. So here, launcher, Equinox launcher, whatever.jar. So this is the actual launcher for the language server, and that is actually what we're getting here with this JDL path /plugin/org equinox launcher dot whatever. Okay, so let's go ahead and take a look at the OS. So if we cd dot again and ls, so now we can see config _Linux ARM, config Mac, config, and then Windows. So you can see the different config directories that we were looking at there. And then finally, we have our Lombok jar. So once again, we have our lombok.jar. So that is where all these is going. It's basically just getting where all of this stuff is installed. That way our NeoVim can know where all this is installed whenever it goes to talk and start up the server and everything else. So now we need to go ahead and set up a utility function that'll set up our debugging and our testing capabilities for us. So once again, we're going to go ahead and say local function, and this one's going to be called get bundles. And this is going to get some different capabilities for us and bundle them up. That way we can pass it to a configuration. Once again, we're going to go ahead and get the Mason registry by saying Mason registry is equal to require Mason registry. We probably could have done this like local at the top of the file. It is what it is. You guys can tweak this however you like. You should probably keep it simple and don't repeat yourself, blah, 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 blah. I don't care. It works. This is what I have for my configuration. You can use it. You can change it. It is what it is. It's your configuration now. So next we want to go ahead and get the Java debug adapter. So to go ahead and do that, we'll do something similar to what we did with the JDTLS. So we'll go ahead and say local Java debug is equal to Mason registry.get package debug adapter. If this freaks you out, this is kind of like a convention you can do if there's is only one parameter, and it's a string in Lua. We could also go ahead and wrap this in curly braces, or not curly braces, parentheses. It does the same thing, so it's mixed in here and there. I didn't do a very good job being consistent. It's because I grabbed these from different sources and kind of put them together to make this actually work to the best of my ability here. And then after we get our package, we want to go ahead and get the full path of this package. So let's go ahead and do that by saying local Java debug path is equal to Java debug path get install path. So again, this is very similar to what we did with JDTLS. We're going to go ahead and get where all of these different files are to access and run this Java debug. So now what we need to go ahead and do is we need to add the jar that runs our debug to a list called bundles. That way we can return it and then pass it to our configuration. So let's go ahead and make a local bundles list. And making lists is kind of similar to making objects and stuff. It's a little bit confusing with Lua, but just know that this is a list and not a table. And what we're going to go ahead and do is we're going to do the same thing we did previously. We're going to use the vim.fn.glob, and we're going to go ahead and concatenate our Java debug path with our extension /server com Microsoft Java debug plugin .jar, and we're going to get the first one basically. That's going to go ahead and add our debug capability to this bundle, and we're going to pass it. And then we also want to go ahead and set up testing capabilities. So to do that, we're once again going to go ahead and get the package for Java test. To do that, we're going to go ahead and say mason registry.get package Java test. It's going to do the same thing it did with our debug adapter in our JDTLS. Again, if you don't like the two without the parentheses, you can go and add parentheses. It's not going to hurt anything. Once again, we're going to go ahead and obtain the full path to the directory that holds all of the different information and all the different files for our Java test. To do that, we'll say local Java test path is equal to Java test get install path. And then we want to go ahead and instead of getting one single jar, we're going to go ahead and get all of the jars for this because there's different ways we can run tests, so on and so forth. So here we're going to go ahead and add all of the jars to this bundle list. And to do that, we're going to go ahead and say vim.list extend. And we're going to go ahead and say bundles because that's the list that we want to extend. We're going to extend it by saying vim.split and then vim.fm.glob. And we're going to go ahead and pass in that Java test path with extension /server.jar. It's going to do the same thing. It's basically going to replace the star here. I misspoke up here. I'm sorry. It's going to replace star with like one thing there. And then it's going to go ahead and split those by new line. So this one here is going to return a whole bunch of jars that kind of explain different ways to go ahead and test and stuff. And then this one's going to go ahead and get the debug runner because that's just going to run the debug script for us, basically, the debug jar. It's kind of like the server, but it's not really like the JDTLS server. It's kind of like a runtime for it, but I digress. I'm not a genius. I just know how to set this up for y'all. And then finally, we want to go ahead and return those bundles. That way we can use them inside of our setup. Cool. So that is one more helper function down, two more to go. Next, we're going to make another helper function, and this is going to be a local function get workspace. And inside, we're going to go ahead and get the home directory of our operating system. So to do that, we can go ahead and say local home is equal to os.getEnvironment home. Now, if you wanted to, you could put this folder anywhere. So you could put this inside of like your user directory or whatever. I just have a specific directory inside of my home directory specifically for code. So that's where I'm going to be putting this. So next, we're going to go ahead and declare what we want it. So I'm going to go ahead and say local workspace path is equal to home. And I'm going to go ahead and concatenate code/workspace. So like I said, code is going to be where I store all like my repositories and stuff on this Linux machine. And then I'm going to go ahead and store project specific information inside the workspace of this code on my home directory, if that makes sense. Next, we're going to go ahead and determine the project name using this magic script here. I don't 100% know what this does, but we're going to call local project name is equal to vim-fm fname modify. So this is going to like modify the name. We're going to get something. So get cwd :p::h::t. This is going to use some magic with basically the full path or the name of the path or something along those lines, and basically pull out what the project name should be. And then we're going to use this to go ahead and set up a specific or unique workspace to store information about our project. You can kind of think of this like Eclipse workspaces for lack of better terms. So now let's go ahead and create the specific workspace directory by saying local workspace. And we're going to go ahead and set this equal to our workspace path with the project name concatenated. So again, this is going to be a unique workspace for a specific project information. Then let's go ahead and return that workspace directory. That way we can use it in our configuration in a little bit. Cool. So that looks good. Now we just have one more helper function, and we're going to get into actually setting up the server itself. The last helper function is going to be called Java Keymaps. So let's go ahead and say local function Java Keymaps. And if you guessed right, this is going to be to set up some keymaps. It's also going to go ahead and allow us to set up some custom like Vim commands that we can run from the Vim command line. So let's go ahead and go through and set up all the Vim commands first. The first thing we want to go ahead and do is set up a Vim command to allow us to call JDT compile. So this will basically allow us to compile the project, and this is going to be a straight up complete compile. So it's going to compile literally everything. To do this, we're going to run a command called vim cmd, and inside of vim cmd, we're going to pass a string with a whole bunch of data about what we want to run. So we're going to run command buffer in args question mark, and we're going to pass some arguments there. Complete is equal to custom, so we're going to make sure it's complete, and we're going to go ahead and call Lua require JDTLS, and then complete compile. We're going to call it JDT compile, and it's going to call compile. So basically, this is just a fancy way of saying whenever we're done with this, we'll be able to say, hey, colon JDT compile, and it's going to run that function from our JDTLS. I don't really need to use this because I have some other stuff set up that we don't need that. It is kind of nice. Next, we're going to go ahead and set up / register a Vim command for being able to update the configuration of our project. So to do this, we're going to go ahead and say vim.command once again, and inside of vim.command, we're going to set the command to JDT update config. So this will be kind of like whenever you refresh your Maven or refresh your Gradle. Next, we're going to go ahead and set up the ability to run JDT bytecode as a Vim command. And to do that, we're going to say a vim.command. The command is going to be JDT bytecode. And this is going to allow us to decompile bytecode into Java classes or Java code. That way you can read it if you ever wanted to do that. And then finally, we're going to go ahead and set up one for the J shell. So let's go ahead and say, let's allow ourselves to do that. And this is going to be vim.command. And this one is going to be for JDT J shell. And this will basically get us a grepl where we could just kind of run and test out our Java code. There's a lot of other ones you can set up as commands as well. There's a couple that I kind of stripped out of the other configurations that I saw just because I would never use them myself. Honestly, the update and the compile are two of the bigger ones, but also it's not that hard to compile Java code with Java P. Not Java P, I don't remember what the command is, but yeah, it's not that hard to compile the Java code manually if you absolutely had to. And I also have a plugin that we're going to talk about later on that helps you out with that as well. So now let's go ahead and get into our Keymaps. So first, let's go ahead and set a keymap to organize the imports manually inside of our project. So to do that, we're going to say vim.keymap.set in normal mode, and this is going to be space shift J plus O, and it's going to go ahead and call that JDTLS organized imports. So basically, this is just going to organize it based on some set of rules. So we'll go ahead and set up later. Next, let's go ahead and we will set up a keymap for allowing us to extract a variable that's under the cursor. So let's go ahead and say vim.keymap.set, and this is going to be space shift J plus V, and this is, like I said, going to go ahead and abstract the code that's under the cursor in normal mode and then put it into a variable for you. Now we're going to go ahead and set up the same keymap, except this one's going to be in visual mode. So let's go ahead and set up a keymap for extracting a variable in visual mode. Once again, we'll say vim.keymap.set. This one will be in visual mode, and it's going to be the same exact thing. Go ahead and extract that value into a variable for us. Let's go ahead and move forward. Next, let's go ahead and set up a keymap for extracting some code under the cursor into a constant. Otherwise, in Java, this would be known as a static. So once again, we'll say vim.keymap.set. This will be in normal mode. This can be for space shift J plus shift C, and this is going to call extract constant. And then let's go ahead and set up the same keymap, but this time in visual mode. So once again, we'll have vim.keymap.set. This one will be in visual mode, and this one will also be for space shift J shift C. Again, I use shift C here because we're going to have something else with JC. So this one is used less often, so that's why it gets designated with the uppercase. Next, let's go ahead and set up a keymap to test the current method under the cursor. So to do that, we'll say vim.keymap.set. And here we're going to have space shift J plus T, and this is going to go ahead and run the nearest method. It's going to be whatever method is under the cursor in normal mode. Let's go ahead and set this up in visual mode as well. So we'll say vim.keymap.set for visual mode this time, and it's going to be the same exact thing. Whatever you select inside visual mode, it'll go ahead and run that test using space plus shift J plus T to run that single test. Now let's go ahead and set up a keymap for running an entire test suite, aka the entire test class. To do this, we'll go ahead and say vim.keymap.set. This one's going to be in normal mode, and this is going to be space shift J shift T, and this is going to call the Lua require JDTLS test class. Again, this is going to test our entire class. And one final keymap. Let's go ahead and set up a keymap to also allow us to go ahead and reload those project configurations, that Maven, that Gradle stuff. To do this, we'll go ahead and say vim.keymap.set in normal mode. This will be for space shift J plus U, and this will go ahead and call that same JDT update config method or function that we were looking at before. I do not know why my spacing isn't working. It's being kind of doo-doo right now, but it is what it is. There we go. That's all of our helper functions. And this is going to go ahead and allow us to set up our configuration a little bit easier. So the good news is we're like halfway there. The bad news is it's going to get a little bit more finicky and a little bit funky. So just bear with me here. So now we're going to actually get into the function that will set up and run our JDTLS server. So let's go ahead and say local function, set up JDTLS. And inside, we're going to go ahead and start getting access to a few things. First, we want to go ahead and get access to the JDTLS plugin itself. So we're going to go ahead and say local JDTLS is equal to required JDTLS. Next, we want to go ahead and get the path to our JDTLS launcher jar, the specific configuration directory and files, as well as the long block jar. So to do that, we're going to go ahead and say local launcher os config and long block is equal to our get JDTLS helper function we set up below. Next, we want to go ahead and get access to the path that we specified to hold our project information. So to do that, we're going to go ahead and say local workspace directory is equal to get workspace, which again is going to go ahead and call that helper method or function that we set up previously. And then finally, we're going to go ahead and get those capabilities or the bundle of capabilities. So to do that, we're going to go ahead and call local bundles is equal to get bundles, which will go ahead and get those capabilities for debugging and testing. Next, we need to go ahead and determine the root directory of our project. So to do that, we're going to go ahead and say local root directory is equal to jdtls.findRoot. And this is going to go ahead and take in a list of different markers that are kind of like define markers that kind of define the root of a project. So things like .git, so wherever your .git folder is, Maven W, so the wrapper for running Maven, Gradle W, the wrapper for running Gradle, the pom.xml, basically the configuration file for Maven, and build.gradle, the configuration file for Gradle. So basically, wherever this is, that's probably going to be the root of the project, and that's where JDTLS is going to look for the main file or the main information about the project. Next, we need to go ahead and tell JDTLS language server what features it's capable of. So to go ahead and do this, we're going to go ahead and say local capabilities is equal to an empty table. And inside of our table, well, first we're going to have workspace is equal to configuration true. So again, I don't 100% know what all these do, but basically in my mind, this is basically telling me, hey, we're going to have a workspace and we're going to give you the workspace directory to go ahead and store that information. And then next we're going to have text document completion, and then snippet support is equal to false. So this one, we're basically saying, hey, don't try to do completion for snippets. We don't have snippet support, so don't try to basically auto include snippets and whatnot. And we'll talk a little bit more about snippets a little bit later on, but those are going to be the capabilities that we go ahead and pass our JDTLS server. And let's make sure that we actually go out of this. Again, I want to go ahead and say that if you do get lost, just go and look at the GitHub repository and make sure and see what you might have missed. Next, we're going to go ahead and get some default extended capabilities of our Java server. So we're going to go ahead and say local extended client capabilities is equal to JDTLS to extended client capabilities. We want to go ahead and modify the resolve additional text support. We're going to go ahead and set this to true. So we're going to go ahead and say extended client capabilities dot resolve additional text edit support is equal to true. Again, I don't 100% know what this does. This is just one of those features that's recommended to turn on. So I just went ahead and obliged. So next we're going to go ahead and set up the actual command that gets run whenever Java starts up our language server. So to do that, we're going to go ahead and say local command is equal to a new Lua table. And inside, we're going to go ahead and bring in the entire command line arguments and everything that gets run. So first, we're going to go ahead and call Java, and this is going to basically run the jar for us. We're going to go ahead and say that we want to run this application. We're going to go ahead and pass in some default start level stuff. I don't fully know what this does. We don't need to, and I missed that. There we go. We don't need to know what that fully does. That's fine. We're going to bring in some other information about another dependency, dev or something. I don't know what the -d stands for, but we're going to go ahead and set the log protocol to true. We're going to set the log level to all. We're going to set the memory to 1 gig for the JVM. We're going to add modules, all system modules. We're going to go ahead and add open Java base util, all unnamed. We're going to add opens for Java based lang, all unnamed. And we're going to go ahead and add the Java agent, which is Lombok, which will basically use Lombok to go ahead and generate all the boilerplate code that we're trying to avoid. This can be -jar. So this is our entire command. We're running Java with all this data and -jar, and then we're actually going to go ahead and find the launcher. So it's going to go ahead and run the launcher jar, and we're going to go ahead and pass in some configuration. We're going to grab the OS configuration that we set up above, which is that folder or directory with all the different configuration, and this is going to be for either Linux, Windows, or Mac, whichever one you chose. And we're going to go ahead and put this data into the workspace directory, which we also specified. So now we're going to go ahead and use our long block variable. We're using our launcher variable. We're using our OS config variable, and we're using our workspace directory variable. So this is going to be, like I said, the actual command that gets ran whenever we start up our JDTLS server. So now we get to the worst part of it, and that is going to basically be setting up all different settings for our Java LSP. You could keep this blank, but these are kind of like the recommended settings, and you can also go through and start looking at more advanced settings and kind of tweaking this as you like. Let's go ahead and configure the settings for our JDTLS server. So we're going to go ahead and say local settings is equal to a new table. And this is where we need to be careful about our indentation and everything. So first thing we're going to go ahead and do is we're going to make another table inside this. And we're going to go ahead and call it Java. And inside Java, first we want to go ahead and enable our code formatting. So to do that, we're going to say format is equal to a new table. And inside we're going to have enable equal to true. So it's going to go ahead and enable our code formatting for us. And next we want to go ahead and use the Google style guide for code formatting. So to do that, we're going to go ahead and set settings inside of Java. And inside of settings, we're going to go ahead, and I think this is actually supposed to be inside of format. I think that I pasted this wrong. So let's go ahead and bring this in. So let's go ahead and select this in visual mode, delete it, bring it up here. I don't see how it's not supposed to be in here. If this breaks, I'll fix it. It is what it is. I mean, I'm not perfect, but we basically want to go ahead and use the Google style for actually formatting code. So let's go ahead and delete this as well. Bring this in, do one of these, and do a paste. There we go. And let's go ahead and fix this. I don't know why it's so jank. But anyway, for the settings, we want to go ahead and say URL is equal to vim.fm standard path for config, and it's going to go ahead and find the language servers and then IntelliJ Java language style.xml. So now, is this actually going to find it? I have no idea. I'm assuming that it's probably either inside the JDTLS, or since we use Mason to install it, hopefully it's there. We'll find out what happens. It'll be interesting. And then next we want to go ahead and set the profile equal to Google Java. Cool. So now we want to make sure that we are inside of Java, but outside of format, because we're finished with formatting. We want to go ahead and enable downloading archives from Eclipse automatically. So to do that, we're going to set an Eclipse table, and we're going to go ahead and set this to download sources equal to true. We want to go ahead and do the same exact thing for Maven. So for Maven, we're going to go ahead and make a Maven property equal to a table. We're going to set download sources inside of that equal to true as well. So whenever we go ahead and declare a new property or a new dependency inside of like our POM or our Gradle, it's going to go ahead and grab those automatically for us. Now we want to go ahead and enable method signature help. So to do that, we're going to set another property called signature help. We're going to set that to a table and say enabled is equal to true for that one. Next, we're going to go ahead and set up the decompiler for whenever we use the Java P command. So to do that, we're going to say content provider is equal to a table, and inside we're going to set the preferred equal to fern flower. Fern flower is just a popular bytecode decompiler to send it back to Java code for us, and that's the recommended one to use here. Next, we want to go ahead and set up some options for whenever we save the Java code. Primarily going to go ahead and set it up to organize our inputs automatically. So you probably didn't need that keymap for automatically doing it, but maybe for whatever reason if it doesn't work, there's a fallback. But to do this, we're going to go ahead and say save options is a Lua table, and inside we're going to have organized imports equal to true. So every time we save a Java file, it's going to go ahead and organize those imports to us, and we're going to go ahead and basically set up how we want these organized a little bit. Next up, we're going to go ahead and customize the completion options, and this is going to basically be like more or less suggestions for popular like methods and things that you might actually install or you might import. So let's go ahead and make a new Lua table called completion, and inside we first want to go ahead and set up some of the static methods and how we should rank them whenever we're trying to bring them in. So to do that, we're going to go ahead and make another table in here, and we're going to go ahead and call this favorite static members, and this is basically going to tell our LSP what the most likely like classes to get these static members from are. So the first one is going to be org.hamcrest.match or assert. So this is going to be basically for testing. Next one will be org.hamcrest org.matchers.star. So again, some of those matchers from JUnit. Then we're going to have org.hamcrest.core-matchers.star, more testing stuff. Then we'll have org.junit.api assertions, again, testing stuff. And then we'll go ahead and get the Java util options require non-null. And then we'll have Java util.objects require non-null else. And finally, we'll go ahead and say org.mockito.mockito. So again, these are more or less, hey, these are the ones that more or less you might be using. Let's go ahead and add a comma here. And next we're going to go ahead and basically tell it, hey, don't show us these for completions. We don't want to see these for code actions. So we're going to go ahead and make another table called filtered types. And inside here, we're going to go ahead and put packages that we don't want to see up in our code completions. So first we'll say com.sun. So we don't want to see any packages or classes from com.sun suggested to us. We don't want to see any from io.micrometer.shaded. We don't want to see any from java.awt. Java.awt is one that pops up a lot when you're trying to import a list for some reason. I don't get why java.util.list isn't the first option, but this will make sure that something other than java.awt typically is going to be util that pops up there. And then jdk. And then finally, we're going to have sun.star. So that'll basically make sure we don't see stuff from them inside of our completion. And then finally, we're going to have one more to set the order at which we want to go ahead and sort our imports. So we're going to go ahead and say import order is equal to a new table. And here we can go ahead and set the package order that we want to import. So the highest priority that'll go on top will be Java. Below Java, we'll say Jarkata, which is going to be basically Java X replacement. We'll do Java X under that because there are still some packages under Java X that get pulled in, such as SQL. Then we'll have com for just general, and then finally org. You could probably put like IO here and other stuff. And if you want to reorganize these, you can, but this is kind of just like the basic that we do. Now we want to go ahead and go below completion, and I'm trying to make sure I don't get this all messed up. There's still a good chance I screw this up somehow and we have to reorganize stuff, but fingers crossed. Next, we want to go ahead and set sources equal to a Lua table. And inside of sources, we're going to go ahead and set up how imports are organized. And basically, it's going to more or less kind of determine how many packages we import into a single file before they start merging those into one single import. So to do that, we're going to say organized imports is equal to a Lua table. And we can go ahead and set up the threshold for how many classes before they actually combine to a single import. So for star threshold, before we actually call like com.package.star to import all of them, we'll say 9999. So you can make this smaller. So for example, if you grab 10 packages or 10 classes from the java.util package, go ahead and turn to a star. We just set it to 9999. That way it doesn't automatically do that. And then next we'll do static threshold to 9999. So again, how many static methods or functions do you bring in before it turns it into one massive import? So now we can go ahead and set up how we want different code pieces to be generated. So to do that, we're going to go ahead and say code generation is equal to a Lua table. And inside here, we're going to set up a couple things. First, let's go ahead and set up how we want toString to be generated. So to do that, we'll go ahead and make a Lua table called toString. And inside the toString, we'll go ahead and template equal to, and we're basically going to set up the template to look like a JSON object. So we're going to say $, which would be like the name, and then object.class name, and then $, member name or member value. And this is all going to be wrapped inside of curly braces, kind of like a JSON string. At least that's how I also like to do my toStrings anyway. So it's nice that it has that. Next, let's go ahead and set up our hash code and equals. So we're going to basically follow the IntelliJ route and use the use Java 7 object. So we're going to go ahead and say hash code equals is equal to a Lua table. And then inside, we're going to go ahead and say use Java 7 objects is equal to true. And this is basically like the default that most IDEs use. So it's going to be the same as any other IDE. And then finally, we're going to tell it to use code blocks whenever we're using this, so it looks a little bit nicer. So use code blocks equal to true. So we're almost done. Under our code generation, we'll go ahead and set up configuration equal to a Lua table. And inside, we're going to go ahead and say update build configuration is equal to interactive. And what this is going to do is if your project ever needs to be restarted and updated, it's going to let you know that before you actually make the changes. You can go and accept the change and then go ahead and update your project. Next, we want to go ahead and enable enable code lens in the LSP. So to do that, we're going to go ahead and say reference code lens is equal to a Lua table with enable equal to true. We'll talk a little bit more about what code lens is near the bottom. And then finally, we want to go ahead and enable inline hints for parameter names. So this is going to be kind of like inside of IntelliJ, whenever you like hover over, it tells you what different parameters you want. So to do that, you're going to go ahead and say inline hints is equal to a Lua table. Inside of inline hints, we're going to have parameters name is equal to a Lua table. And then inside of parameter names, we're going to go ahead enabled equal to all. So again, it should give you hints to what different parameters you have. So this should be right here, should be the end of everything. I believe everything worked out, so fingers crossed. But there's all of our settings. Again, you can go ahead and go on to GitHub and you should be able to see the entire thing here and copy paste if you want. We'll go ahead and use this in a little bit, but this is all of our settings for our Java JDTLS server. Cool. So now we just have like a couple more things to configure. Next, we're going to go ahead and create a table called init options. So let's go ahead and do that. And inside this table, we're going to go ahead and pass some information about like our debugging and testing along with our extended client capabilities. So let's go ahead and say bundles is equal to bundles inside this table. And then we're going to also go ahead and say extended client capabilities are equal to extended client capabilities in this table as well. So this is just going to be some extra information that we pass along to our configuration. And now we get down to the fun part and the final part, which is setting up our onAttach function. So let's go ahead and say local onAttach is equal to a function that takes an underscore and buffer number. Again, I don't think that we need either of these. Maybe in the original setup, it was using the buffer number, but this is kind of like how function call looks for onAttach. So that's the way it is. So let's go ahead and whenever we attach our language server, let's go ahead and map the Java keymaps. So let's go ahead and say Java underscore keymaps and call that keymap function. And we only want to go ahead and set these once our server is attached. Now you could have set all these like in LSP config. It probably wouldn't hurt anything to have them. It's just better not to do it that way. That way people aren't trying to call Java functionality things on code that isn't Java. Next, we want to go ahead and set up our Java debug adapter for the JDTLS server. So we're going to go ahead and say require JDTLS.dap.setupDAP just to go ahead and set that up. Again, if you want to go ahead and wrap this inside curly braces, that is also legal. It saves you a couple keystrokes. It is what it is. Next, I want to go ahead and talk about a function call that we're going to go ahead and do. So let's go ahead and bring in these notes. We're going to go ahead and call a method called setup DAP main class config. And let's go ahead and just bring it in for the heck of it. So we're going to go ahead and require JDTLS.dap.setup DAP main class configs. And again, if you want to wrap this inside parentheses, that's also fine. This is supposed to find the main method or methods of the application so that the debug adapter can successfully start the application. Now that's what it's supposed to do. However, in the plain old documentation, it says that it's not recommended to actually run it inside of the onAttach function because the entire JDTLS server might take too long to start up for the project and then it won't actually be able to find that main method. That's why sometimes you'll get a class def not found exception whenever you try to run the debug tool. If this does occur to you, there's a couple options here. You can either attempt to run the debug tool again inside the main class of the application, and that'll typically find it. Let me fix this typo really quick because this is going to be going up on GitHub. Or you could try to restart the NeoVim instance, go ahead and restart the language server and then hope it works. Unfortunately, I haven't found a very elegant way to get this working like 100%. Right now it works like 99% of the time, and sometimes it's just random files where it won't work on. So for whatever reason, the controller class wouldn't work sometimes, which is weird, but whenever I went to like the service class, it worked. So yeah, it's a little bit funky. This is the only downside of using Vim with Java. Other than that, I've been loving it so far. So again, there's a way around it, and also just keep checking back probably on my actual NeoVim configuration because I'm going to go ahead and link my personal configuration, which is going to be based off this, but I'm going to make some tweaks here and there and kind of add some extra stuff that I've seen. Again, like I wanted to mention, this is like almost as bare bones as you can get with a lot of these setups. So I'm going to expand upon mine. You can take a look at mine and see if I will find a better solution for this. For now, it is what it is. So next we want to go ahead and enable JDTLS commands to be used in NeoVim. So this is going to also allow us to kind of use some of those other commands as well. And then finally, we want to go ahead and refresh the code lens after we have all this set up. And like I mentioned before, we'll talk about the code lens. So basically the code lens is what's going to enable the features, such as like how many references to a piece of code, the different implementations, and also kind of like the different code actions that you can take on a piece of code. So shorthand, this is kind of, I don't want to call it the glue, but this is where a lot of the functionality with like the IDE type of stuff comes in. So we want to go ahead and refresh that to see if there's any new counts for implementations, references, things like that. The last thing that we want to go and do is set up a auto function that will basically refresh our entire Java project whenever we write to a Java file. So to do that, we're going to go ahead and start out by saying vim.api.nvim_create_auto command. And inside this function, we're going to go ahead and basically say what event do we want this to run on. We want to go ahead and say buff write host. So basically this means after we write to a buffer, we want to do this. Let's go ahead and pass in a Lua table for options. And what we want to go ahead and do is we want to say the pattern of the file or buffer that we wrote to is .java. So anytime we write to a Java file, we want to go ahead and run this auto command, and we want to set up a callback function to run a specific function anytime this happens. So we're going to say callback is equal to a function, and inside this we're going to go ahead and make a procedural call to vim.lsp.codelens_refresh. I don't 100% know what like procedural calls, what the p call does. It's something special. Still relatively new to NeoVim, still learning, but basically more or less this is just going to go ahead and refresh our entire codelens again. That way we can see any new reference counts and things like that. So now we are ready to go ahead and set up the config to run or attach our JDTLS server, which will actually get things working. So let's go ahead and make a new table called local config, and inside of local config we're going to go ahead and pass in our command that we set up above. So command equal to command. We're going to go ahead and pass in the root directory of our project that we found above. So root dir is equal to root dir. We're going to pass in those settings that we set above. So settings equals settings. We're going to go pass in our init options that we set above. So init options is equal to init options, and this holds the bundles to our debug and testing as well as the extended client capability. And finally, we're going to go ahead and pass the on attach, which will tell the server what to do whenever it attaches. Finally, the last thing that we need to do to get this working, we need to go ahead and start the JDTLS server. So to do that, we'll go ahead and say require JDTLS.startOrAttach.config. Finally, we need to go ahead and return this function so we can actually call it instead of an auto command whenever we start a Java file. So to do that, let's go ahead and return a Lua table. And inside the Lua table, let's go ahead and say setup_JDTLS is equal to setup_JDTLS. Now we can save that, and if we close that in NeoVim, we're not going to see anything here because we didn't actually set up any new plugins or anything like that. But this is going to be the entire setup. Again, I know it went a little bit quickly here, and this is going to be the longest part of the entire tutorial, and this is going to be the most important part. So if you want to, you can always go through, copy paste it directly from our repository, or you can follow along is what it is. But let's go ahead and get the server actually up and running whenever we start up a Java file. Since we're not starting up the JDTLS server as soon as our NeoVim instance opens up, we need to actually tell NeoVim when to start the server or when to attach the server to a specific buffer. So to do that, let's go ahead and open up our file explorer, and inside of our config, we're going to go ahead and say A to make a new file. And we're going to go ahead and make a new file called auto cmds.lua. So this is going to hold different auto commands. We want to go ahead and set up an auto command to specifically run the JDTLS server whenever we open up a Java file. So to start out, we're going to go ahead and say vim.command with a double set of square brackets. So this is the other way you can set up a auto command. This is kind of like the old school way that they suggest whenever you do it inside of like a regular script like this. Next, we're going to go ahead and say aug group or au group is equal to JDTLS_LSP. So this is basically going to make it so that this only runs like once. That way there's no conflicting issues and we don't double run it. And we're going to go ahead and also say au group end at the bottom of this. That way it knows it's the end of the auto group. Then inside the auto group, we want to go ahead and say auto command bang to start the auto command. And then we want to go ahead and set up the auto command. So the auto command will start with auto CMD. We want to watch for the file type to change. We want to watch when the file type is equal to Java. And if it's Java, we want to go ahead and call require.config.jdtls.setJDTLS. So we're going to go ahead and call the setup JDTLS function that we went ahead and set up in the config.jdtls, and that'll either go ahead and start the server or go ahead and attach the server to our Java file. That way it can give us different information about the file. So let's go ahead and save this. Now we need to go and open up this and go back into our init.lua, and we need to actually require this. Let's go ahead and load this by saying require config.autocommands. We can go ahead and save this. We're going to go WQA and close out of everything, and fingers crossed this doesn't crash. Okay, that's good. Let's go back into this other tab here, and let's go and cd back into home, cd in the code, ls. Now I have this product service project here that I just kind of worked on a little bit for this specific project or specific tutorial. So let's go and say nvim product dash service. Go ahead and enter, it'll open it up. So we're not going to see anything right away, but let's go into our source main project, go like that, and hopefully you can see Java server starting, and there we go. Our highlighting is working. Everything is good to go. I'm not going to go through everything in our LSP right now because there's a lot more features that I want to go ahead and set up before we actually start writing Java code, but this is working. You can even, if we come into here, maybe we go into like our services just really quick, just to kind of show you like code actions and stuff. So let's just say that we like want something here where we can say like public map of string and product, and then we'll say fetch product map. So this is not going to be something that we actually want. It shouldn't know what map is. So you can see, hey, map cannot be resolved as a type. So if we hit space CA, it's going to give us options. So we can either import map, we could come back up, we can import map from there, we can add all missing imports, you know, we can do all of this. We can even change final. So that's something that's kind of unrelated. But we can generate delegate, generate toString, so on and so forth. So that's what's kind of cool about this. Let's go ahead and delete this. We don't want this. I'm going to go ahead and do a larger demo at the end of the project or configuration after I get everything set up. Let's see also if I can get that issue to work. So if I go into controllers, sometimes if we go ahead, well, actually we can't test the debugging yet because I don't have debugging all set up. We might be able to test the testing. So we come into our product service test, and we come in here and we go ahead and say, I think it's space JT. It's running the test. I don't know if it passed. It says all passed. We're going to set up a better way of kind of viewing tests. It's still not 100% perfect. And honestly, I might still technically like running the test manually using the Java command or the Maven command, but you can see that it passed. It doesn't work perfectly even on save, so sometimes you have to save multiple times because I was trying to make the test fail on purpose. It's there, it works. There are some quirks, but for writing code, it's really nice. Some people use the terminal anyway. So with that being said, I'm gonna go ahead and quit out of our Java code, hop back into our configuration, and let's hop into the next plugin that we want to go ahead and set up. Let's go ahead and continue working on getting more of our code-related plugins working before we actually go ahead and do a little bit of a demonstration of all the things put together here. So let's go ahead and open up our Explorer here, and then let's go into our plugins. Let's go ahead and hit A. We're going to go ahead and make a file called nvim-dap.lua. And let's go ahead and go into nvim-dap.lua and close out of our Explorer. Nvim DAP is going to be basically a plugin that allows us to configure our debug adapters. Technically, we already had this installed for us whenever we set up our JDTLS, but what we want to go ahead and do is come in here and actually set up some Keymaps. That way we can actually use it to start debugging, add breakpoints, and also be able to open and close out of the UI that gets popped up whenever you go ahead and start debugging. So as always, let's go ahead and start out by returning a Lua table that will have our plugin spec inside of it. And then inside, let's go ahead and include the GitHub shortened URL. So that's going to be whatever that is, I don't want to butcher the name, /nvim DAP. We are going to have a couple of dependencies. These are going to be primarily for the UI side of things. So let's go ahead and make a dependencies table. And inside the dependencies table, first we're going to go ahead and bring in the shortened GitHub URL for Nvim DAP UI. Again, this is going to make debugging a little bit easier because it's going to have a nice debug experience, a nice debug UI similar to IntelliJ or Eclipse. And then we're also going to go ahead and bring in Nvim Neo, which is going to be another like utility plugin that that's used for the UI that's going to make things look nice. So next we can go ahead and set up our config function. Let's go and say config is equal to a function. And inside our function, we're going to go ahead and do a couple of things. First, we want to go ahead and gain access to the DAP plugin and all of its functions. So go ahead and do that. We're going to say local DAP is equal to require DAP. And this is going to go ahead and grab that Nvim DAP for us. And next, we also want to go ahead and gain access to our UI plugin. So to do that, we're going to go ahead and say local DAP UI is equal to require DAP UI. So we're going to go ahead and use the DAP to go ahead and set up some key mappings, and we're going to go ahead and use the DAP UI to be able to open and close the DAP UI. So the first thing that we want to go ahead and do is set up the DAP UI with our default configurations. So to do that, we're going to go ahead and say DAP UI.setup, and this is just going to configure things for us with default stuff. Again, if you want to take a deeper look into this, you can. There's probably some things you can configure here, but for us, bone stock is just fine. And then what we need to go ahead and do is we need to set up an event listener to know whenever the debugger is launched. That way it knows whenever we need to open up the UI. So to do this, we're going to go ahead and say dap.listeners.before.lapui_config is equal to a function. And then inside this function, we're going to go ahead and open up the debug UI. So to do that, we're going to go ahead and say dap.ui.open. So basically what this is going to do, it's going to set up an event listener, kind of similar to like how you do in JavaScript or whatever, what other event driven language you're using. Whenever it hears this specific event, basically, so whenever we hear a launch event, before we actually launch the program or launch debugger, we're going to go ahead and open up that UI. That way we can use that. Next up, we want to go ahead and set up some key mappings. So the first key map is going to be to actually create a breakpoint for the code to actually stop at. So to do that, we're going to go ahead and say vim.keymap.set in normal mode, and this is going to be to space plus d plus t. And this is going to go ahead and call dap.toggle_breakpoint. And this is going to go ahead and do as it says. It's going to go ahead and toggle a breakpoint. That way, whenever we start debugging, if our code does go through that flow, it'll go ahead and stop there. Next, we want to go ahead and create a key map for actually starting up the debug mode. So once again, to do that, we're going to go ahead and say vim.keymap.set in normal mode. And this is going to be for space plus D plus S. And here it says dap.continue, but basically dap.continue will either restart the debug server, or it's going to go ahead and start up the debug server. So you can either restart it or go ahead and start it up. So that's going to just stay in for debug start. And finally, we're going to set up one more key map. This one had it set up in a different way inside of a different configuration I saw, but it didn't really work properly in the way that I wanted to. So we're going to go ahead and set up a key map to just manually close whenever we're done. That, and sometimes whenever it stops or whenever you terminate the debug server, we don't always want to close out the debug UI. Maybe we just want to restart the debugger to start from a different spot. So to do this, we're going to go ahead and say vim.keymap.set. So space D plus C. And I'll probably go through and comment this out a little bit better. That way, whenever I upload this to GitHub, you guys can know what's going on here. And this is going to call that dap.ui.close. And this is to close the debug menu. So now this is all we need to go ahead and do. So let's go ahead and say W to go ahead and write that. And I'm just going to go ahead and quit all. Let's go ahead and nvim init.lua to go ahead and install all of our nvim DAP stuff. We already had nvim DAP installed, but we go ahead and grab that UI in the nvim neo. We can go ahead and quit out of that, and that is good to go. So we could go ahead and take a look at the DAP stuff, but I want to go ahead and kind of continue on with the rest of our code related things, just to kind of get everything all set up. And then here at the end, once we have everything set up, I'll go ahead and take you through the project once again. We'll try to step a little bit of code, and I'll show you all the different things they can do with the configuration. So that being said, let's go ahead and hop into our next plugin. So to continue on with our next plugin, as always, we're going to go ahead and hit space E to open up our Explorer. Let's go into Lua, plugins, hit A, and then we're going to go ahead and make a file called springboot-nvim. So springboot-nvim .lua, and go ahead and enter, and let's go ahead and go into Spring Boot Nvim. So Spring Boot Nvim is a small plugin developed by yours truly to enhance the experience of writing Java applications in NeoVim, specifically Spring Boot projects. It comes with a few nice features, including recompiling your code on save so that the Spring Boot dev tools actually works, automatically including package declarations on created Java files. So for example, if you go ahead and just create a Java file inside of your code, it'll go ahead and automatically just put the package import in there for you. That way you don't have to write that. I know it's something really small, but it is pretty nice. And it also provides pop-up windows to help you easily generate classes, interfaces, and enums, just like how IntelliJ has pop-ups for creating those things as well. I do plan to go ahead and add more features in the future, but for now, I just wanted to go ahead and ship an MVP for this specific setup tutorial. If you are interested in learning some Lua and want to help develop new features for the plugin, I'm open sourcing it, so don't hesitate to open new feature requests or create a PR with better code or new features that you want to see. So with that shameless plug out of the way, let's go ahead and start configuring this. So as always, we're going to go ahead and return our Lua table with nothing inside of it. Then we want to go ahead and grab the shortened GitHub repository URL for Spring Boot-nvim. Next, we're going to go ahead and include a couple dependencies. So let's go ahead and say dependencies is equal to a Lua table. And inside of our dependencies, we're going to go ahead and bring in nvim-lsp config. This is because I want to make sure this is installed, because I do use a couple of functions from nvim-lsp plugin to determine what our package structure looks like. And then we're also going to go ahead and bring in nvim JDTLS. Once again, I'm using this inside the plugin to kind of get some information about the project and help out with creating classes and things of that sort. So now all we need to do from here is go ahead and create our config function. And inside the config function, the first thing we want to go ahead and do is get access to the Spring Boot nvim plugin and all of its functions. So as always, for this, we're going to go ahead and say local Spring Boot _nvim is equal to require Spring Boot nvim. And now we're going to go ahead and set up all the different key mappings that we're going to use to access the different features of Spring Boot nvim. So the first thing we're going to go ahead and do is we're going to set a key mapping to be able to start up our Spring Boot application inside of a terminal while we're working on the project. To do this, we're going to go ahead and say vim.keymap.set in null mode. And this is going to be for space shift J plus R. This is going to go ahead and run the Spring Boot nvim boot run function, which will open up a terminal inside your NeoVim and go ahead and start running the Spring Boot application. And then of course, with that automatically compile every single time you write to a Java file, it'll also go ahead and restart the application every time you write to a Java file as well. Next, let's go ahead and set up a key map to make it so we can pop up the generate class UI. So to do that, we're going to go ahead and say vim.keymap.set in null mode. This is going to be for space plus shift J plus C for Java create class. This is going to go ahead and call it Spring Boot nvim.generate class, which will go ahead and pop up a UI that'll ask you for the package declaration as well as the class name, and then it'll go ahead and create that class file inside the correct package for you. Next, let's go ahead and create a key map for creating interfaces. So this is going to be very similar to the previous one. We're going to go ahead and say vim.keymap.set in null mode. This is going to be space shift J plus I, and this is going to call the generate interface. Again, this is going to be for Java create interface. And then finally, let's go ahead and set up a key map for creating enums. So to do this, we're going to go ahead and say vim.keymap.set in null mode for space shift J plus E. And again, this is going to open up that generate enum UI to go ahead and create an enum in a specific package for you. So the last thing that we need to go ahead and do is run the setup function with a default set of configurations. And this should set up some other things for us, like those auto commands and other things to do some magic. To do this, we're going to go ahead and say Spring Boot _nvim.setup with an empty table inside of it. And then it'll go ahead and just set up the default configuration. So now let's go ahead and save this. So say WQA. And let's go ahead and open up init.lua. And now it's going to go ahead and install Spring Boot nvim for us. We can go ahead and quit out of that. And again, that is another code related one down. So let's go ahead and continue working and inch our way closer to an IDE experience here. Moving forward here, we're going to go ahead and set up a plugin that will go ahead and help us out in formatting our code and making things look a lot nicer. So let's go ahead and hit space E to open up our Explorer, go down to our plugins, hit A, and then let's go ahead and make a file called none-ls.lua. Go ahead and hit enter. Go into none-ls and go ahead and close out of our file explorer. So just a little bit of background here. So none-ls was previously known as null-ls until its owner of the repository decided that they could no longer update the plugin, and they went ahead and deprecated the package. However, it was such a loved plugin that the community decided to make an open source fork of null-ls and keep it up to date. However, this doesn't exactly tell us what none or null-ls actually is. So none-ls is a plugin that manages linters and formatters for us, similar to how LSP Config works. We're basically going to tell it what formatters that we want installed and when we want to use them, then it'll go ahead and get them and set them up for us. So with that being said, let's go ahead and get our linting and formatting going and go ahead and get this even closer to an IDE. So as always, we're going to go ahead and return an empty Lua table. And inside the Lua table, let's go ahead and bring in the shortened GitHub URL for the none-ls repository. Next, we are going to go ahead and need a set of dependencies. So let's go ahead and say dependencies is equal to an empty table. And inside the table, we're going to go ahead and bring in a dependency called none-ls extras.nvim. So we're going to go ahead and bring the shortened GitHub URL for this. And this is going to go ahead and build some extra things on top of none-ls. Cool. So next, let's go ahead and set up our config function below the dependencies. And inside of here, we first want to go ahead and get access to our none-ls plugin and functions. So let's go ahead and say local null-ls is equal equal to required null ls. Now here things are a little bit strange. If you remember, I said this is a direct fork of null ls. So whenever we set things up, we're going to go ahead and still use namings from the old conventions, so the old package. However, this is going to be using non-ls, so sorry for the confusion here, but that's the reasoning behind it. They didn't want to completely rewrite everything. They literally just forked it, and now they keep it up to date. So with that being said, now we can go ahead and set this up. So let's go ahead and run the null-ls.setup function, and inside of the null-ls setup function, we're going to go ahead and set up our different sources for formatting. So to do that, we're going to go ahead and make a property called sources and set this equal to a list. And inside the list, we're going to go ahead and set up some formatters and linters that will help us out with our code. First, we're going to go ahead and set up the Lua formatter. So to do this, we're going to go ahead and say null_ls.builtins.formatting.style Lua. So it's going to go ahead and use the style Lua formatter to format our Lua code for us. Next, let's go ahead and set up ESLint for linting in JavaScript. So to do this, we're going to go ahead and require nonls.diagnostics.eslint_d. So this is going to go ahead and set up our linting for us in JavaScript. And finally, let's go ahead and set up Prettier to kind of basically format all the other things that aren't JavaScript. So now we're going to go ahead and say nonls.builtins.formatting.prettier, and basically this is going to go ahead and do it for everything that's not like Lua other than Java specifically going to go ahead and use that Google style. So just kind of keep that in mind, but this will kind of work for like our JavaScript and anything else. There are also some other linters and other formatters. So if you wanted to use like something for Python or something else like that, you could definitely set that up as well. But this is for Java and like TypeScript/React type stuff. So we're going to go ahead and keep it at that. Cool. So let's go ahead and do one more thing. We need to go ahead and set up a function or a key map to actually be able to format our code for us. So to go ahead and do that, we're going to go ahead and say vim.keymap.set. This is going to be in normal mode, and we're going to go ahead and say leader cf or code format, and this is going to go ahead and call the vim.lsp.buffer format, and that's just going to go ahead and the LSP is going to look for different formatters that we have installed and then decide which one we want to use. So let's go ahead and save this, and then let's go ahead and WQA to go ahead and save and quit out of everything. Let's go ahead and open up nvim init.lua. It's going to go ahead and install null-ls as well as the extras. Let's go ahead and quit out of this. So now, for example, if we like add a whole bunch of space here and say space cf, it's going to go ahead and do that. I don't know why it says failed to run generator. It did work. We might actually have to do one thing here. Let's go ahead and open up Mason, and we might actually have to get the prettier and everything like that in ESLint. So let's go ahead and Control F. Let's go ahead and look for style Lua. I don't know if it's going to pop up. No, it did not. So let's Control F and just look for Lua. And let's see. So we want style Lua. So let's go ahead and go to style Lua and hit I. And then let's go ahead and Control F for JS for JavaScript. We're going to go ahead and grab prettier. So go ahead and hit I on that. And then I don't know what to do for ESLint. Maybe let's go to 4. Okay, I don't see anything there. Well, actually, let's go ahead and escape the language filter. And then let's just go ahead and scroll down until we see ESLint. And it's ESLint D. Go ahead and hit I. So there we go. Now we have the linters installed. I'm surprised it still worked technically. So let's go ahead and WQA to get rid of that. Nvim, and then hopefully let's see if it still complains, and space cf. There we go. So you got to make sure that these are installed. Unfortunately, nonetheless doesn't actually install it for you. I should probably go through and make sure that the Google one is also installed. I don't remember what it is. We can actually probably take a look. So we can say space space E, and I broke it, space E. There we go. And go into our config JDTLS. We're going to get a little bit sidetracked here. So we are looking for a scroll down. Ooh, we never used capabilities. I think we're going to come back to that. That's fine. So we want to look for IntelliJ Java Google styles. So let's say :Mason. Let's go into our, this will be like 5 or formatters, and let's see if we can find Google. Actually, never mind. I already have Google Java format. I'm going crazy. That's good to go. We are going to circle back here in the next section and set up those capabilities. So let's go ahead and just go back to our init.lua, and then let's go ahead and move on to the next section. Our next plugin is kind of like the final step to really get that full IDE-like experience, and this is going to be our auto completions. By default, NeoVim actually has no clue what auto completions even are, so that's where we're going to go ahead ahead and install several plugins here to tell NeoVim what options we have. The standard plugin for auto completions and code snippets is going to be called Nvim CMP. So we're also going to be bringing in a couple of other plugins that work with Nvim completions, including Lua Snip, which will give us VS Code like completion snippets, CMP, nvim-lsp, which will go ahead and use the active LSP server to provide smarter and more accurate completion options for the user, as well as a couple of other ones, including path and buffer, to give us some just plain text completions, as well as path-based completions. With that being said, let's go ahead and reopen our File Explorer. Let's go to our plugins, hit A, and then let's go ahead and say cmp.lua. And then inside of cmp.lua, let's go ahead and enter space E to get rid of that. So this one is going to be kind of like the last complicated one. This one you have to be kind of safe. We are going to be passing in a couple of different things, or a couple of different tables here to pass in different or return different plugins, but they're all related to completions. And we're also going to have to go back into our LSP config and our JDTLS to go ahead and update some of our capabilities to tell our LSPs that they are actually capable of completions. So it's going to be a little bit of moving parts here, so just be careful, as well as you can get access to the repository if you do miss something. As we always do, we're going to go ahead and return the Lua table from our cmp.lua, and inside we're going to go ahead and set up another table to set up our first plugin here. So the first plugin is going to be Lua Snip. So let's go ahead and bring in the shortened GitHub URL for Lua Snip, and then here Lua Snip is going to have a couple of dependencies. So let's go ahead and make a dependencies array. So we'll go ahead and say dependencies is equal to a table, and inside we're going to go ahead and pass in the dependency called CMP Lua Snip. So we're going to go ahead and bring in the shortened GitHub URL, and this is going to go ahead and feed Lua Snip suggestions over to CMP for us, so you can kind of see it like a bridge. And then we're also going to go ahead and bring in friendly snippet, which will give us specifically the VS Code like snippets for things like HTML and other things. So let's go ahead and bring in the shortened GitHub URL for friendly snippets. So this is what we're going to have to set up our Lua Snip. Next, we're going to go ahead and add in another Lua table for our next plugin, and this one is going to be for CMP nvim-lsp. Like I mentioned before, this is going to work with our LSP to actually feed suggestions over to CMP to give us more options for completions. Here, all we want to go ahead and do is pass in the shortened GitHub URL for CMP nvim-lsp, and then after we get our CMP kind of finished up, we'll go back to LSP config in our JDTLS and go ahead and set up our capabilities with our language server to actually provide us with these completions. So now let's go ahead and set up the big one. So go ahead and do one more table, and inside we're going to go ahead and bring in the shortened GitHub URL, and this is going to be the one for our completion engine. So let's go ahead and bring in the shortened GitHub URL for Nvim CMP. We're going to go ahead, and whenever we insert enter inside of NeoVim, we're going to go ahead and load this. So we're going to go ahead and say event is equal to insert enter, and then we are going to have a couple dependencies in here. So let's go ahead and make a dependencies table, and inside the dependencies table, first we're going to bring in CMP buffer. So we're going to go ahead and bring in the shortened GitHub URL for CMP buffer, and this is going to give us buffer based completions. This is going to be just like basic text things that the LSP or basically the CMP buffer can grab from text files. It's going to be less advanced than our LSP, but it might give us a couple good completions here and there. And then we're also going to bring in the shortened GitHub URL for CMP path, and this is going to give us some path based completion options. So if you're trying to get a specific path or relative path or things like that, it'll go ahead and give you some information there. Let's go ahead and set up our config function to get this all working. And inside of our config function, first we want to go ahead and gain access to CMP. So to do that, we're going to go ahead and say local CMP is equal to require CMP. And then we also want to go ahead and gain access to Lua Snip. That way we can get some of our snippets working. So to do that, we're going to go ahead and say local Lua Snip is equal to require Lua Snip. Next up, we want to go ahead and lazily load the VS Code like snippets whenever we actually need them. So like whenever we start seeing completions, or maybe the LSP is actually going to have a completion for adding like a snippet, such as creating an HTML file. So to do this, we're going to go ahead and say require luasnip.loaders.from_vscode.lazyload, so that I go ahead and set up those HTML and other type of snippets like that. Then we need to go ahead and call the CMP setup function. So let's go ahead and say cmp.setup with a Lua table, and inside of our table, we're going to go ahead and set up how our completion menu should look. So to do this, we're going to go ahead and say completion is equal to a table, and inside the table, we're going to have complete options dropped equal to menu1 preview and no select. So this is basically going to describe how the menu is going to look and behave. So first off, menu is basically just going to go ahead and display the options in a menu for us. It's going to be a drop down. Menu 1 will automatically select the first option inside the menu. If you don't want this to be the default, you can go ahead and get rid of menu 1 completely. Preview will go ahead and display the completion candidate as you navigate the menu. So it's kind of basically going to have like a ghost text kind of effect where it's going to show you what the completion will look like in your code. And then finally, no select will go ahead and prevent NeoVim from automatically selecting completion without you actually hitting enter inside the menu. That way you don't actually just like every single time you move, it just puts something in there. So you have to actually hit enter to grab that, which is nice because sometimes you don't even want it open. You just want to close it and keep moving on with your life. So next, let's go ahead and actually set up the snippet support. So go ahead and do this. We're going to go ahead and say snippet is equal to a Lua table. And inside the Lua table, we're going to go ahead and say expand is equal to a function with arguments. And inside of our expand function, we're going to go ahead and say Lua snip.lsp underscore expand args body. So again, this is just going to go ahead and enable and set up our active LSP as well as snippet support with that active LSP. So this is more or less going to say, hey, we're inside of a JSX file. Maybe we should show them the RFCA to create a React function arrow component, for example. Cool. So now we need to go ahead and set up how we can interact with our tables or our menu here. So this is going to basically be the key mapping section. So what we want to go ahead and do is you want to say mapping is equal to cmp.mapping.preset.insert. We want to go ahead and set up our key maps. So first what we're going to go ahead and do is we're going to set navigating to the previous selection to Control K. And this is going to go ahead and call cmp.mapping.select previous item. Next, we're going to go ahead and set up navigating to the next item. So this is going to be Control J. So we'll set Control J is equal to cmp.mapping.select next item. So you can go up and down the list. And then if you want to scroll the docs really fast, so maybe it's a really long document or a really long list of different completions, and you want to go multiple at a time. First, we'll go ahead and say Control B to skip down 4 items. And then we're going to go ahead and say Control F to skip up 5 items. So this is going to call cmp.mapping scroll docs -4 and scroll docs 4 respectively to go up and down 4 items at a time. Next, we can go ahead and turn on the completions. So basically open up the menu, and we're going to go ahead and set this to control space to open up the window if we ever close it ourselves for whatever reason. And if we do not want the menu to be open, we can go ahead and set up Control E to call cmp.mapping.abort. So like I said, sometimes you don't care what completions are. You already have it all written down and still trying to do a completion. You can go ahead and just say Control E, get that sucker out of there. We don't want it there. And then finally, we want to be able to actually confirm a completion option. To do that, we're going to go ahead and set that as enter. So this is only going to go ahead and work while you're actually inside the menu. So you can go and then scroll up or down, find that you want, go ahead and hit enter, and it'll go ahead and confirm that for you. Close out of the menu, you go on with your life. That's going to be all of the mappings. Next, we're going to go ahead and set up the actual sources for completions. So to do that, we're going to go ahead and say sources is equal to cmp.config.sources, and this is going to be a Lua table inside of a function. And this is really important. This is going to be basically order matters here. So whichever order that these are in, it's going to be basically rank them importance. Whatever is on the top will be the most important on our completion, and then it'll kind of go down the list. So first, we're going to go ahead and set up nvim-lsp. So we're going to set up another table and say name is equal to nvim-lsp. Then we'll go ahead and do our snippets. So to do that, we'll go ahead and say name is equal to Lua snip. Then we'll go ahead and just do some basic text-based ones. So here we'll say name is equal to buffer. And then finally, we'll say name is equal to path for just some path-based ones. And I just want to go ahead and say before we move on and set up the actual LSP part of the completions, you can also go ahead and look into other completion sources if you like. I know that there's some for like emojis. If you want to go ahead and pick an emoji for your code, I don't condone emojis in code, but if you're that type of person, you can do that. And there's other ones for like GitHub Copilot and other AI program tools that are similar to Copilot that can give you completions that way as well. I just want to keep things as simple for the tutorial as possible. So now, like I mentioned before, we actually need to go ahead and set up the LSP completion. So to do that, we're going to say space FF, and let's go ahead and look up for our LSP config and go into there. So what we need to go ahead and do is inside of our LSP config setup, we need to pass in a couple things. So first, let's go ahead and set up the capability for actually being able to do auto completions. So to do that, we're going to go ahead and say local capabilities is equal to require cmp underscore nvim underscore lsp dot default capability. So this is going to go ahead and basically tell our LSP that it's capable of auto completions. And then what we need to go ahead and do is pass in these capabilities to each of our language servers. So inside of our LSP config.lua_ls.setup, we want to go ahead and pass in capabilities is equal to capabilities. And we want to do the same thing inside of our TS server. So then we're going to go ahead and pass in capabilities is equal to capabilities. We can go ahead and W that space FF. Let's go ahead and go into JDTLS.lua. We need to do kind of like the same thing. So let's go into our capabilities here. So below our capabilities, let's go ahead and do the same thing and say local LSP capabilities is equal to require cmp_nvim_lsp.default capabilities. And now since we already kind of have a table here, we need to do a little bit of magic. So we're going to go ahead and say is for k comma v. This will be key value in pairs of our LSP capabilities. So we're going to go ahead and loop through all of the LSP capabilities that we got from our CMP nvim-lsp. We're going to say do, and then we're going to call capabilities k is equal to v and then end. So this is going to loop through all of the capabilities inside of our LSP and then go ahead and basically append them on to the capabilities. So now we actually need to go ahead and use this inside of the setup, which I forgot to do previously. So let me go ahead and take a look at how to do this again, just so I don't mess it up. So we want to go ahead and scroll down to where we have our config object or table. I keep calling it an object because of my JavaScript brain. They're really tables. So here below the settings, we're going to go ahead and pass in capabilities or equal to capabilities. And then this will go ahead and pass in all the different capabilities that we just set up. Save WQA to go ahead and close out of that. Let's go ahead and hit enter to go ahead and install everything. Hopefully everything works. Sometimes things are a little bit slow here, but that's good to go. So now, like sometimes if we start typing in here, we'll probably see in a little bit that we'll actually see some pop down. So it'll say, hey, do you want to do this? Do you want to do that? Again, this is kind of like the final step. This is kind of how like other IDEs do it as well. It'll give you suggestions for things that you might want to do. So with that being said, let's go ahead and start getting into some of the more optional ones that you may or may not use. So if you want to just stop right here, I absolutely understand. You technically don't need any of the other ones, but the rest of these are going to be more or less just quality of life things that kind of make NeoVim a little bit more fun to use, make things a little bit easier on yourself. So let's go ahead and keep moving. At the end of the entire tutorial here, we'll go ahead and do some work on this Java project, and I'll kind of show you all the different features of our LSP and IDE like experience here. So moving forward here, let's go ahead and open up our Explorer. Let's go into our plugins, go ahead and hit A. We're going to make a file called auto pairs.lua. Let's go into auto pairs, space E to go and get rid of this. So as we mentioned, this is going to be a quality of life plugin that'll go ahead and automatically close your curly braces, your square brackets, your parentheses, and more. And then this will really give us that like VS Code / IntelliJ feeling once we get it all set up. So as always, let's go ahead and into insert mode, and let's go ahead and return a Lua table. Inside of our Lua table, let's go ahead and bring in the shortened GitHub URL for the repository of this plugin. So it'll be winwp nvim-auto pairs. Here, once again, we're getting an event. So whenever we insert enter, we'll go ahead and set this up. So we'll say event is equal to insert enter, and we are going to have a dependency. So let's go ahead and say dependencies is equal to a Lua table, or I guess technically this is a list, but it is what it is. And this is going to be nvim CMP. So we're going to go ahead and make sure that our auto completion is set up for this to work. Then we can go ahead and say config is equal to a function like we have been. And now you can go ahead and see how we have that open. Of course, we don't care. So we can go ahead and just say Control E to get rid of that. Go ahead and up here. Whoops. There we go. So the first thing that we want to go ahead and do is just set up our auto pairs functionality. So to do that, we're going to go ahead and say require auto pairs.setup and pass it a object. Again, if this freaks you out, you can go ahead and have parentheses. It's going to be doing the same exact thing. So inside of here, we're going to go ahead and set up a couple things. First, we're going to go ahead and say check TS is equal to true. Next, we're going to go ahead and say TS_config is equal to a object or a Lua table. And inside, we're going to set up a few properties. First, we're going to say Lua is equal to a string inside of a list. Next, we're going to say JavaScript is equal to template string inside of a list. And finally, we're going to say Java is equal to false. So Java is going to be used using something else. It's not going to be using like this TS config. So we're going to go ahead and set it to false. Don't worry, it's still going to go ahead and get those sweet automatic opening and closings. So now let's go ahead and get access to the CMP auto pairs function. So to do that, we're going to go ahead and say local CMP_auto pairs is equal to require nvim auto pairs.completion.cmp. We're also going to go ahead and gain access to CMP as well, our completion engine. So we're going to go ahead and say local CMP is equal to require CMP. So basically what we want to go ahead and do is anytime we go ahead and choose an auto completion that requires us to close like a set of parentheses or maybe like quotes or something, we want to go ahead and make sure when we hit enter on that, it goes ahead and closes that for us just so it can be a little bit convenient. So what we're going to go ahead and do to fix this is we're going to go ahead and say cmp.event on, and we're going to say confirm done. So whenever we confirm done inside of our CMP or our completion engine, it's going to go ahead and also say cmp autopairs.on confirm done. So like I mentioned before, if we choose a choice from an auto completion that needs a pair finished for it or closed for it, it'll go ahead and do that for us. So let's go ahead and say WQA to go ahead and save and quit. Let's go ahead and open up Nvim to go ahead and install this. So and quit. And now if we go ahead and let's say, let's see, module auto pairs not found. So I typoed something. Let's go ahead and see what's going on. Whoops. And let's go space E. Maybe this one we might have to do it the silly way. So require auto pairs dot setup. And maybe I typoed something as well, nvim auto pairs. Let me just go ahead and double check this. Although I don't understand why it can't find it. And then let me just double check nvim dash auto pairs dot completion cmp. That should all be good. Just let me double check everything. I might have changed something slightly. I did. So this should be require. So here, this should be require nvim dash auto pairs. Like so. Let's go ahead and WQA, open this up. Okay, so now if we open up a parenthesis, it closed the parenthesis for us. So if we open up a square bracket, it opened up the square bracket. We open up this. So as you can see, whenever we do stuff like that, now we have all these different completions with different code documentation, other things like that. So that is cool as well. That's our auto completion working. So now, as long as I actually do things properly, our auto completion and our auto pairs is working. So let's go ahead and move on to our next quality of life plugin. Next up, we're going to go ahead and take a look at a couple of Git plugins. One of them is really nice and I use it a lot. The other one I've used a little bit, but I still kind of like an old school, just use Git in the command line. So I added it in here because it's pretty useful, but you guys can kind of decide whether or not you want to use it or not. And again, most of these at this point are going to be pretty optional and just kind of make your life a little bit easier and make the IDE a little bit better. Because I know in like IntelliJ, there's options for Git and stuff. So I mean, I kind of added it in there as well. So to go ahead and do that, let's go ahead and say space E to open up our Explorer, go to our plugins, hit A. Let's go ahead and say git.lua and go into git.lua. For Git, we're going to go ahead and do a couple of different plugins here. The first plugin is going to be called Git Signs, which is basically going to go ahead and give us indications of which lines of a file have been changed. And it's even going to go ahead and allow us to view changes made to the file directly inside the file that's open. So basically you can go ahead and view different hunks or previews and see what the old code was and see the new code beside it, all without having to leave your editor, which is super nice. And then the other plugin is going to be called Vim Fugitive, which is an old school Vim plugin that also works inside NeoVim, which is going to allow you to run Git commands directly inside the NeoVim command line. So basically if you were to say like Git whatever, it's going to let you do that. We'll even set up some keymaps so you don't have to type it all out. And then Git Fugitives also allows you to easily git blame and do some other things as well. It can show you git blame directly inside Vim, so everything looks nice. So if that sounds pretty cool to you, you can go ahead and continue here. So let's go ahead and say return a Lua table, and then inside the Lua table we'll have another Lua table because we are going to be returning a couple of different plugins here. So first, let's go ahead and set up Git Signs. So let's go ahead and bring in the shortened GitHub URL for Git Signs. This is from Lewis6991. What a cool Git name. And then all we need to go ahead and do is just set up something pretty simple. So let's go ahead and say config equal to function. And inside of our config, we're first going to go ahead and set up Git Signs. So to do this, we're just going to go ahead and say require Git Signs.setup with default properties. Nothing crazy there. And then we're going to go ahead and set up a key mapping to actually be able to view the different changes inside the file. So to do this, we're going to say vim.keymap.set. This is going to be inside normal mode to space G plus H. And this is going to go ahead and call Git Signs preview hunk. Preview hunk is basically going to be like a hunk of changes inside of your code. So it'll show you the old one and then the new one and then decide whatever you want to do with it. It's kind of like Git history from IntelliJ. If you've ever used IntelliJ, it's pretty cool. And then that's all we're going to go ahead and do in here. And that's all we're going to use Git Signs for. Whenever we set up Git Signs by itself here, it's going to go ahead and set up in the sign column, plus signs for new code, minus signs for deleting code, and then like tilde or like whatever the squiggly line is for modified code. And you can do changes to this whenever you do the setup. Again, I'm going to probably have some more advanced stuff in my personal GitHub. So if you want to go ahead and take a look at my personal NeoVim configuration, my old configuration had some changes in Git Signs to make it look a little bit pretty, but I don't want to say dumb this down. I made this more basic. That way you guys can explore and you guys can kind of modify this to your liking, and then I'll go ahead and modify into my liking. And if you do want to see my more advanced one, you can go ahead and check out the description down below. So that being said, let's go ahead and set up our next Lua table for Fugitive. And inside the Lua table, let's go ahead and return the shortened shortened GitHub URL for Vim Fugitive. And then once again, this one's going to be pretty simple. We're just going to go ahead and say config is equal to a function. And inside, all we're going to go ahead and do is set up some keymaps for accessing some basic Git commands. So first, let's go ahead and set up a keymap for seeing the Git blame. So to do this, we're going to say vim.keymap.set. In normal mode, it's going to be space G plus B for Git blame. And if I wanted to, I could probably go in here and do like this, Git and then blame. Again, I got a little bit lazy, I think. Either that or I copy pasted not everything that I wanted. I'll clean this up before I actually push the final version. But there is a reason why I'm kind of following this convention that we'll see here in a little bit. So next up, we're going to go ahead and set up another keymap. So this is going to be a keymap for adding all the files, or like git add dot. So to do this, we're going to say vim.keymap.set. In normal mode, this will be space plus G plus shift A, and this is going to go ahead and run git add dot to add all the files to the staging area. Again, the description will be git add all. I'll go ahead and comment this up and make it look a little bit nicer before we push it up. Next, we're going to go ahead, instead of key mapping, to go ahead and just add a specific file, the file that we're on right now, to the staging area. So to do that, we'll say vim.keymaps.set in normal mode, and this will be space G plus A, and this will go ahead and just call git add to add the current file. We're going to go ahead and set up a couple more. Next, we're going to go ahead and set up a keymap for committing the staging area. So we'll go ahead and say vim.keymap.set in null mode for space G plus C. This will go ahead and call git commit, and it'll also go ahead and ask you for like a message. And finally, we're going to go ahead and set up a key mapping for git pushing to the branch. So this will be vim.keymap.set space G plus P for git push. I do want to go ahead and preface by saying that I've experimented with a little bit. Git add and git commit work really well, and git blame work really well. However, I've had not as much luck with git push, so you might need to go ahead and play around with this a little bit. Again, this one's completely optional. I'm still basically using the actual terminal, the git bash, to actually push all my stuff, but I want to go ahead and add this just so it's an option. But I did want to go ahead and warn you that this is like the one plugin, and specifically the git push is like the one thing I haven't fully nailed down yet. So experiment with it. There might be like something that we need to slightly change here. If you do find like what we need to slightly change, you can go ahead and also let me know inside of the comment section below. But with that being said, let's go ahead and WQA as we do. Open up Vim. Go ahead and open this up. Now the issue is that this is technically not a GitHub repository right now, and neither is the other one, so I won't be able to actually kind of like show you the changes and stuff, but you'll see in the left gutter whenever you're actually working all the different things. I also can't git blame or preview hunks or anything, unfortunately, because I don't really have any Git repositories to open up right now, but you can kind of experiment with it and make sure everything works. You have all of the key mappings right there in front of you. You should be able to see that. Cool. So let's go ahead and move on to our next plugin. Our next plugin on deck is a completely stylistic plugin. It's just going to make our NeoVim look pretty, basically. So if you don't want to use this, I understand, but this one's a pretty basic plugin, and basically everyone that you'll see on YouTube is using it to kind of spice up their NeoVim configuration. And this plugin is called Lua Line. So Lua Line is, like I said, a stylistic plugin that adds a little information line at the bottom of your NeoVim. And like I've said, you've most likely probably seen it while watching others using NeoVim. So it's absolutely not required, but it makes your editor look a lot prettier, and it's pretty nice, so why not add it? So let's go ahead and say space E, go into our plugins, say A, let's go ahead and say Lua Line.lua, go into Lua Line and get rid of our editor. Let's go ahead and return our Lua table, and inside of our Lua table, let's go ahead and bring in our Lua Line shortened GitHub URL, which is going to be nvim-lua-line, lualine.nvim. Next, we're going to go ahead and have one dependency. So let's go ahead and make a dependency list with dependencies equal to curly braces. And inside of our list, we're going to go ahead and bring in the shortened GitHub URL for nvim dev web icons. So this is going to go ahead and just bring in some nice little web dev icons inside of our Lua Line. I'm going to copy and paste some like icons that you'll see in a little bit. You have to get them from the GitHub repository or from Lua Line. But if you don't have a nerd font installed, unfortunately this won't work. So if you want to use this, make sure you have a nerd font installed. If you don't have a nerd font installed, go ahead and skip that part. Now let's go ahead and set up the config function. And inside the config function, we're going to have quite a few lines, but everything's going to be fairly simple and straightforward. So let's go ahead and call the Lua Line setup function with a table inside of it. And this is going to go ahead and allow us to define the properties of how our Lua Line will actually work. So first, let's go ahead and first enable our web dev icons if we have a nerd font installed. So to do that, we're going to go ahead and say icons enabled equal to true. Again, if you do not have a nerd font installed, go ahead and set this to false. It's not going to work, but I have a nerd font installed, so it should work out. Next, we want to go ahead and set the theme. So personally, I'm going to go ahead and set the theme to Dracula. If you want to set it to a different theme, that's completely fine and up to you. I like Dracula and it's going to go ahead and match. A lot of people use Dracula anyway for the Lua line, even though they're not using Dracula as the background color. Again, you can go ahead and explore the Git repository. They'll kind of show you all the different themes that they have. The different themes are going to have different components in them and things like that. So I definitely recommend you just go ahead and take a look. So next is the part that I'm going to have you guys go ahead and copy either from my GitHub repository or from the Lua Line GitHub repository. And the first one's going to be for component separators. So we're going to go ahead and insert this. So for our component separators, we're basically going to have these like chevrons to the left or to the right. And these are going to be basically like different pieces of text that are inside the bottom line. And then next, we actually need section separators. So once again, I'm going to copy and paste these from the repository. This is exactly what the Lua Line just basic configuration is. So if you want to look in there, you can. But basically, this is just going to be like a solid triangles whenever we actually separate the different sections. And you'll kind of see, and this will all make sense in a little bit once we kind of get this all set up. Next, we're going to go ahead and disable a couple things. So we're going to go ahead and set up the status bar and win bar. So to do that, we're going to go ahead and say disabled underscore file types is equal to a table. And inside, we're going to say status line is equal to an empty table. And we're going to say win bar is equal to an empty table. Next, we're going to go ahead and make it so that whenever we're inside the Nvim tree, we're not going to actually focus and set a whole bunch of information that we don't actually need. To do that, we're going to go ahead and say ignore focus is equal to a Lua list with Nvim tree inside of it. Next, what we want to go ahead and do is we always want to divide the Lua line exactly down the middle. So to do that, we're going to say always divide middle equal to true. And then we're also going to go ahead and disable the global status. So to do that, we're going to go ahead and say global status equal to false. And then we want to actually set some refresh information on when to go ahead and refresh the information inside the Lua line bar. So to do this, we're going to go ahead and say refresh equal to a Lua table. And inside of our refresh Lua table, we're going to say status line equal to 1000. We're going to go ahead and say tab line equal to 1000. We're going to go ahead and say win bar equal to 1000. So the only one we're really going to be using is the status line. The tab bar is kind of like at the top if you have tabs open. We're not getting to the tabs in this one because that's kind of, I don't want to say it's a more advanced Vim feature, but it's outside the scope of just setting up our Java configuration. I have no idea what the win bar is. You'd have to probably research that. With the status line at the bottom, whenever we make changes or whatever, it's going to update every 1 second. So next we want to go ahead and set up what the different sections do. And the sections are going to start at A on the left side, and then it's going to go over to Z on the right side. So A will be the first, B will be the second, so on and so forth. So we're going to go ahead and say sections is equal to a Lua table. And the first thing we're going to do is we're going to go ahead and display the current mode that we're in inside of section A. So to do this, we're going to go ahead and say Lua line underscore A is equal to mode. So this will go ahead and display the current mode in Lua line A. Next, we're going to go ahead and set up the current branch, any get differences, and any code diagnostics inside of section B. So to do that, we're going to say Lua line underscore B is equal to branch diff and diagnostics. And basically the diagnostics will have like some symbol or something if the file that you're in has a diagnostic or you're hovering over diagnostic, something similar to that. And then finally in section C, we're going to go ahead and display the file name. So to do that, we're going to say Lua line C is equal to file name. And then we're going to go ahead and say, okay, we're going to stop at C. This is going to be all the components on the left side. So it's going to be split in the middle. So now we're going to go ahead and start working on the right side. So first we're going to go ahead and display like the type of the file, the operating system, as well as the encoding of the file. So to do that, we're going to say Lua line X is equal to encoding, file format, and file type. Next, we're going to go ahead and display where we're at inside the file and section Y. So to do that, we're going to say Lua line Y is equal to progress. And finally, we're going to go ahead and display the exact cursor location inside the file that we're currently in. And to do that, we're going to go ahead and say Lua line Z is equal to location. So that's going to be all of the active sections. Now we want to go ahead and set up what each section is going to look like whenever it's inactive. So to do that, we're going to go ahead and say inactive sections is equal to a Lua table. And inside, we're going to go ahead and display nothing in sections A and B. So we're going to go ahead and say Lua line A is equal to nothing and Lua line B is equal to nothing. And then inside of Lua line C, we're going to go ahead and display what the file name is. So to do that, we're going to go ahead and say Lua line C is equal to file name. And then once we split in the middle, we're going to go ahead and say Lua line X, which is like the first one on the right side, is going to be equal to location. So where we're at in the file specifically. And finally, we're going to go ahead and have nothing and Y and Z. So this is going to say Lua line Y is equal to nothing and Lua line Z is equal to nothing. So that's cool. there. So now we're just going to go ahead and set some default values for tab line, win bar, and inactive. So let's go ahead and add the comment for that. So to go ahead and set default for tab line, we'll go ahead and say tab line is equal to an empty table. For win bar, we'll go ahead and say win bar is equal to an empty table. For inactive win bar, we'll go ahead and set that to an empty table. And finally, we do not have an extension, so we'll go ahead and say extensions equal to an empty table. So now we can go ahead and W, make sure I don't do it incorrectly. W, we can say WQA. So again, like I said, this is a little bit longer, but it's also pretty simple. It's just basically telling you how we want different things. And again, the GitHub is going to go ahead and give you more information about what different components. These are all the different components you can put in there. You can go ahead and modify it. You can add a different theme. You can do whatever you want. Let's go ahead and WQA. Let's go ahead and say nvim init. Hopefully I went ahead and did all this right. If we go ahead and say Q, now you can see on the bottom of our screen, we have our Lua line. So here you can go ahead and see this is our first section, section A. And you can see how it has that like little triangle there, and we're in normal mode. If we go ahead and hit I, we're in inset mode. If we go ahead and hit V, we're in visual mode, so on and so forth. Then on the right side, you can go ahead and see that we're in UTF-8 mode. Remember that we set all this to UTF-8 anyway. Then we have like a little line break here. We have our little Linux penguin. He's so cute. Then we also have our file type, which is Lua. And then here, the progress is basically like, okay, how far down the project are we? And then you can also see the exact location of our cursor. So right now we're on line 17, column 1, 2, go up and down, so on and so forth. So that's our Lua line. It looks nice. A lot of customization here that you can go ahead and just rice up yourself. So I didn't want to kind of make all the decisions for you. So basically, if we go ahead and say space FF again, go back to our Lua line, go into Lua line. This is basically copy paste from the GitHub for their regular old configuration, other than I set a theme myself because I knew that I like Dracula. So yeah, go ahead and explore, make this look nice once you're a little bit more comfortable with Vim, make it look exactly like you want, put whatever you want. You can put different diagnostics like what time it is, you know, like how much CPU you're using, like crazy stuff like that inside the Lua line. And you can also go ahead and make your tabs look really nice as well. With that being said, we can go ahead and start moving on to the last couple of plugins here. Then we'll go ahead and get into a demo of what our end IDE actually looks like. Next up, we have a really good utility plugin called WhichKey, which is going to allow the developer to see which key mappings are available based on the prefix that they just used. So this is why I've been following a very certain convention inside the description of our key mappings. So for example, after we get WhichKey installed, you'll be able to hit the space key for our leader, and then you'll be able to see all of the different key mappings for the prefixes that we already set. So let's go ahead and say space E to go ahead and open this up, go into our plugins and hit A, and let's go ahead and say WhichKey.lua. Go into WhichKey and close out this, and let's go ahead and get started. You guys are getting real tired of me saying this, but as always, let's go ahead and return a Lua table. And inside the Lua table, let's go ahead and bring in the shortened GitHub URL for WhichKey. This is by Folky. He's apparently a GOAT of Nvim. I don't know much about Nvim yet. I'm still getting new, but apparently just everyone knows he's the GOAT. Now for the event, as soon as we enter Vim, we want to go ahead and load this plugin. So event will say equal to Vim enter. And then next, let's go ahead and set up our config function, which will be pretty simple. All we're going to do inside of it is set up our key mappings. So inside of our config function, let's first go ahead and gain access to the WhichKey plugin by saying local WhichKey is equal to require WhichKey. Then we want to go ahead and just call the setup function normally. So we're going to go ahead and say WhichKey.setup. And then once we have this set up, now we want to go ahead and register all of our prefixes. That way we can have a list of all of our different key mappings. So to do that, we're going to say WhichKey.register with a table. And inside the table, we're going to go ahead and register all of our different prefixes that are going to go ahead and be leader and then whatever. So first, let's go ahead and say leader slash. And do this, we're going to go ahead and say square brackets and then leader slash. And the name of this prefix is going to be comments. And then we're just going to go ahead and use a function equal to WhichKey ignore. I don't 100% know what this part does. This is just standard. You guys can look a little bit deeper into that. Next, let's go ahead and set up one for our code. So we're going to go ahead and say square brackets leader C. This one's going to go ahead and map to our code related key maps. Next, let's go ahead and set up one for debug. So once again, we're going to go ahead and say square brackets and then leader D or space D. Next, let's go ahead and set up one for explorer. So this one will be square brackets leader E for explorer. We're going to go ahead and set one up for our finding. So here we'll say square brackets leader F for find. We'll set one up for our git So this one will be square brackets, leader G, and the name will be equal to get. And then we'll do one for Java related keymaps. So this will be leader uppercase J. It's very important. This is an uppercase J that waits shift J. This one will be for Java. And then finally, we'll have one for creating windows. So this will be leader W, which will go ahead and say, hey, you can go ahead and create windows with that. So again, this one's very simple and it's a great utility. It doesn't hurt to have. Let's say WQA. Let's go ahead and open up our init. Okay, which key is installed? Whoops, go ahead and quit instead of right. So now if we go ahead and hit the space bar, it's going to go ahead and pop up. You can go ahead and see all of our different mapped key mappings. So if we say slash, it'll add comments. We haven't gotten to adding the comment yet. We'll go ahead and do that. If we say C, it'll show us the code related ones. If we say D, we'll see the debug related ones, so on and so forth. So if we go ahead and say like C, you can see, hey, we have our code actions, our definitions, so on and so forth. Hit escape to close out that space. Some of the Java ones are showing up. They probably shouldn't, but if we say shift J, you see our create class, create enum, create interface. And since we're not in the Java file, we don't have all of the testing ones. These are just going to be the ones that are coming from Spring Boot Nvim. Hit space again, and we can go ahead and say, okay, what finding ones do we have? And you guys can go ahead and continue doing that same kind of like convention for the description. So if we say space FF, and then maybe let's go into, I don't know what one has key mappings, maybe Telescope has key mapping. So yeah, so you can go ahead and continue doing this, like find whatever. You can kind of continue following this convention, and it's going to go ahead and look nice inside of which key. That one was a very simple one. Let's go ahead and do the last couple ones here. So we're going to go ahead and move on to another simple one that's going to help you a lot with file navigation. So we're getting really close to the end here. Next, we're going to go ahead and set up a plugin called Harpoon, which is built by the Prerequisite. If you haven't heard of him, he's a pretty prominent YouTuber, used to work at Netflix, uses Vim, by the way. You know, if you haven't heard of him, look him up. He's a great person, great developer. I watch his videos all the time, watch his live streams. He's very entertaining. But yeah, so we're going to go ahead and set up his plugin. So his plugin's called Harpoon, and Harpoon's a plugin that allows you to mark files inside your NeoVim instance to be able to quickly navigate between them. So this is used for whenever you have a set of specific files that you're currently working on and then need to go back and forth between them very quickly. So instead of opening up the File Explorer and searching for the file, or even opening up Telescope and typing out the file that you're looking for, you can just go ahead and hit a key map for Harpoon, go ahead and go to the specific file that you want and hit enter, and you'll be there in no time. It's a lot faster than doing a whole bunch of keyboard stuff. So once again, let's go ahead and space E to go into our plugins directory, hit A, we're going to go ahead and say harpoon.lua and go into our Harpoon space E. This one is dead simple to set up. We're going to go ahead and return our Lua table as always. We're going to go ahead and bring in the shortened GitHub URL for the Primogen/Harpoon. We're going to go ahead and say this is going to be a lazy. So we only want this to load whenever we actually use it. So let's say event is equal to very lazy. And we also have one set of dependencies here. So let's go ahead and make our dependencies array. And inside of our dependency array, we're just going to have the shortened GitHub URL for plenary.nvim. Again, we mentioned Plenary earlier. This is basically just a utility plugin that helps other people build UIs and other things for their plugins. And finally, all we need to go ahead and do is set up our config function. So config is equal to a function. Now we just have a couple of simple keymaps. So first, let's go ahead and set a keymap for actually creating a file mark. So to do this, we'll say vim.keymap.set, and the convention is just to use Shift M to go ahead and mark a file with Harpoon. If you guys want to use like HM or something, you can definitely do that as well. I just kind of followed the convention that everyone else uses. And we're going to go ahead and set up one more keymap to actually open up the quick file navigation. So to do that, we're going to say vim.keymap.set in normal mode tab, and then this is going to go ahead and run the quick toggle menu. So basically, you can mark a file with Shift M, and then you can go back to that file by just saying tab and then going to whichever file that you want. So again, this one's a very simple one. So we say WQA, open up Nvim and let that install, quit. So now let's go and say space FF init.lua. Okay, this isn't that slow. It is what it is. But if we go ahead and say Shift M, it'll go ahead and mark the file. If we say tab, it didn't mark it. Let me make sure I did it right. Shift M and then tab. There we go. So we have init Lua. I think I did Control M. So then let's say maybe we're working in space FF. Let's say that we're working in our Harpoon file, for example. So let's look up Harpoon. We can go ahead and say Shift M to mark that. So now we can just go ahead and go to init, go tab, go down, tab up. Pretty quick there. So if this is really useful for if you're actually just working on a couple files, maybe 3 or 4 files, go on and off. You can navigate to them very quickly rather than like space FF, typing in here looking for whatever. So now we just have one final plugin left. So let's go ahead and get into that, and then we'll get into our demonstration with everything all put together. Alrighty, so our last plugin is just straight up utility plugin that's going to be made to make our lives way easier, and it basically implements the same functionalities like control or command slash and IDEs like IntelliJ to easily comment and uncomment blocks of code for us. So let's go ahead and say space E, go to our plugins, hit A, we're going to go ahead and say comment.lua, go into comment.lua, and go ahead and let's return our table. We're going to go and get right into this. So next we're going to go ahead and pass in our shortened GitHub URL for comment, as we always do, and then we're also going to go have an event that loads this up. So here we're going to go ahead and say event is equal to a Lua table, and this is going to be whenever we read a file. So before we open up the buffer file, we're going to go ahead and run this, or whenever we create a new file, we'll go ahead and initialize this. We're also going to have a dependencies array. So let's go ahead and say dependencies is equal to a new list, and inside our dependencies we're going to go ahead and bring in the shortened gib URL for nvim.ts context comment string. And what this is going to go ahead and do is it's going to allow us to smartly comment out TSX elements. If you guys have worked with React, you know how much of a pain it is to just comment these out normally. So this is going to help us out a lot and allow us to comment out those TSX elements more easily. Next, let's go ahead and set up our config function. And inside of our config function, we just basically need to set up a couple of keymaps and also set it up so that we can actually go ahead and comment out those TSX elements. So first, let's go ahead and set up our keymaps. The first keymap will be to go ahead and comment and uncomment inside normal mode. So we're going to say vim.keymap.set leader slash or space slash, and this is going to go ahead and run comment the current line. So whatever line your cursor is currently on, it'll go ahead and comment that out for us. And then let's go ahead and also set up a comment command for visual mode. So to do that, we'll say vim.keymap.set in visual mode. This will be space and then slash, and this will go ahead and comment out all of the code that's selected. Again, I didn't go ahead and put the square brackets around these ones just because obviously I didn't really see is already used. It is what it is. So now we actually need to go ahead and set it up so that whenever we try to comment out TSX elements, it actually works. So to do that, first we need to go ahead and gain access to the comment plugin and all of its functions. So we're going to go ahead and say local comment is equal to require comment, and then we want to go ahead and gain access to that TSX commenting plugin. So to do that, we're going to go ahead and say local ts underscore context underscore comment string is equal to require tx underscore context underscore comment string dot integrations dot comment underscore vim. What a mouthful, am I right? And then we want to go ahead and call our comment dot setup with an empty Lua table, and inside here we're going to go ahead and pass in prehook is equal to tx underscore context underscore comment string dot create prehook, and this is going to go ahead and allow us to use this tx context comment string to go ahead and comment out our TSX elements more easily. So let's go ahead and say WQA to close out of that. Let's go ahead and open up Nvim to install that. Cool, it is installed. Let's go ahead and say space FF. Let's go back to our comment, go into our comment, and let's go ahead and just take a look at this. So a lot of people do this to like GCC, which I don't really love. I don't really know where GCC even comes from as like a keymap. I'm more familiar with like the slash, whenever you say control slash, and it'll go ahead and comment stuff out for you, and like IntelliJ. So now if I hit space slash, you can see it went ahead and commented it, space slash, it'll commented it. And then if we go ahead and go into visual mode, let's go ahead and just like select two lines here. Let's go to the end of the line. Technically don't need to go to the end, it is what it is, space slash. I went ahead and commented that out. Let's go ahead and uncomment this. Let's go ahead and go back into visual mode. Let's go ahead and say space slash again. It'll go ahead and uncomment it, save it, CF to go ahead and format it, save it again. There we go. So that was quick, easy. Then we can go ahead and comment out large chunks of code pretty quickly there, and it'll be a lot nicer than going ahead and just adding slashes or anything else that you have to do. So that's going to be all of our different plugins. Now I'd kind of like to go ahead, and you've seen some of these in action, but you haven't actually seen any of these in action with actual Java. So what I want to go ahead and do is I want to hop into our Java code, our little product service application, and I kind of just want to go ahead and add like a new service maybe, and show you guys kind of how things are going, maybe show you guys our testing, and also show you guys debugging and things like that. So let's go ahead and hop into that project, kind of take a look at our IDE experience, and then have our closing thoughts. Now we're inside of a new terminal instance. We can go to ls, and let's go ahead and cd into product-service. This is where our product service code is. You can see we have here Nvim, and then we'll go ahead and just say dot and just open this up. So as always, this is just going to be a very simple project that I set up specifically for this video. So let's just go into source main Java com resources, and let's just take a look at our product. Go ahead and get rid of this. So this is a very simple product. You can see that our service is up and running. Everything's good. Our language server is going, and we have our entity. We have a couple things. So for this little demonstration, I'm going to show you guys some of the keymaps that we set up specifically for our code related stuff. Is we're going to go ahead and add a product type onto our product here, and then kind of do some other stuff just to kind of show you guys all the different key mappings that we have. So to start, we're going to go ahead and hit enter, and we should go ahead and see our which key. So we're going to go ahead and shift J, and then let's go ahead and make an enum. So E, and hopefully I don't have any typos. It looks like I still need to get rid of a print statement. You can see down here, last time I tried using this, it didn't work 100%. I typoed something, but I believe I fixed that. By the time this video goes out, I'll go ahead and make sure all of the issues are ironed out, all the little bugs and stuff. But here we want to go ahead and put this into our models. Except I need to spell models right. So models, we can go ahead and hit J to go ahead and add the enum, and we're going to go ahead and call this product type. We hit enter, it takes us to the product type of a space E. You should see now we have product type inside of here as well, so that is good. Inside our product type, let's go ahead and add physical. So physical and digital. So we're going to add a physical and digital product. So W compiled successfully. So you can see that whenever we saved, it went ahead and auto compiled as well. Cool. So let's go space FF. Let's look for our product, and let's see here. So let's find our product.java. There we go. So now what we want to go ahead and do is we want to go ahead and add this as a column. So we can go ahead and hit enter, go ahead and say at column, and we can go ahead and you can see that it has the pop-up, so that's nice. But if we go ahead and actually just ignore that, we can say space CA for code actions, and you can kind of see the different actions here. Let's see, I don't see import. Oh, you know what? It's because we already have at column. That's fine. So we actually going to go ahead and say at enumerated as well, and then this one shouldn't exist. So this one we should be able to say space CA, and then hopefully it lets us import this. So let's see, add Java doc generate. For some reason it's not letting us import, so let's just go ahead and just finish this up, and then maybe after we add the product type and everything, so we'll say public product type, type, and we can also hit enter here, and that'll bring in the product type, or at least it should. We might have to actually go down, hit enter, and import it. I don't think we actually have to import it since we're inside the models package, but I digress. Go ahead, and I don't know what we want to call this. Maybe we'll just call this type like so, and do like that. Whoops, and put our semicolon. Oh, you know what? I'm stupid. We're already importing all of the Jakarta stuff. That's why the code action isn't working. That makes sense. And then in here, we're gonna go ahead and just add in the last thing that we need, which is the enum type. And then this is going to be dot ordinal. If I could type. I said I was going to try to get better at typing. Doesn't mean that I did. There we go. And then it actually went ahead and exploded out this. So it went ahead and organized everything, and that's good to go. So let's go ahead and see like a couple other code actions. And also this should be private. What am I doing? So private. Cool. And then now we have an issue where all of these getters and setters and toString are out of date because we added in this type. We could just add it, but let's just go ahead and delete that. So to create a constructor, we can say space CA. Let's go ahead and go to constructor. And here we're going to say 1, 2, 3, 4. So we'll go ahead and just hit the number and then enter and then escape, and that's going to go ahead and create that constructor for us. And then we'll go ahead and say space CA. Let's go ahead and generate getters and setters. So generate getters and setters. I went ahead and generate all those. Space CA. We go ahead and generate toString. And again, we're going to do the same thing. So 1, 2, 3, and 4. We don't care about the gets or anything. We can go ahead and hit enter, and there we go. So now we have a full constructor and everything like that. We have issues. Let's see, what is the issue? Oh, you know what? These are issues in product service and everything like that. We're going to go ahead and fix that in a little bit. Actually, we can go and just fix that now just to get that fixed. So close out of that. And this is actually a good time. We can probably say space FD. We can see all of our different issues. So let's go ahead and go in here. And the issue is here. We're not passing in this constructor. So we're going to go ahead and here, let's just say a product type. And then we'll go ahead and say dot, and this will just be a physical product or something. And W, we still have issues because of our product service. This was the product service, still need to go product service test. So say space FD for more diagnostics, go to the service test. And then here we'll go ahead and add the product type dot physical. So physical, same thing. You can say product type and then dot physical, and then same thing. Product, if I could type product type dot physical. So it's going to give us a very similar feel and everything of a Java compiler or a Java IDE, and it's working very similarly. So that went ahead and showed off some of our code actions and whatnot. So let's go ahead and run the application. So now I'm going to go ahead and go back into like the main application. So let's say product service application, maybe just to be safe. So we say space once again, and which key will pop up. Let's say J, and then we'll go ahead and say lowercase r to run the application. And I just want to make sure that the database is still working and everything after we add the entity. Otherwise I'll debug it off screen, because again, this isn't about writing a Spring Boot application. This is more about just setting this up. The only other thing that I'm a little bit concerned about this is the issue of the fact that I don't think I have this on create drop. But again, this is not a Spring Boot tutorial. I'm just kind of showing you some of the different things we can do with our setup. Cool. So we gotta make this a little bit smaller just so I have a little more space. Cool. So that's good to go. So now what I want to go ahead and do is kind of expand the functionality of our application here. So let's go ahead and say space FF. Let's go ahead and find our product service. Go into our product service. So we're gonna go and rename this to be physical product service, and we're going to go ahead and make an interface to basically implement so we can kind of see some of the other features. So go ahead and say space. This is going to be inside code, and we're going to say shift R to rename. And we're going to go ahead and rename this to physical product service, and go ahead and hit enter. And it's going to go and rename that literally everywhere. It recompiled, and our Spring Boot application should have also restarted. And then I'm also going to go ahead and add a new annotation on this just to be safe. So we say at, and we're going to go ahead and say qualifier. So qualifier, like this. And here we say space CA for code action. We can go and import qualifier. Now it's working because I didn't just import all. And then this is going to go ahead and say physical, maybe physical product service. And this is that way we can distinguish between different product services. There we go. And we can see our Spring Boot is reloading. Everything good, except we have an issue with product controller, yada yada yada. That's because we set qualifier. That's fine. It doesn't know which one to choose, so that's fine. I'm gonna go ahead and quit this. I don't want it running right now. And then escape a couple times, colon Q. Cool. So now let's go ahead and take a look at being able to create a interface. So we're going to say space, and then we'll say uppercase J, I for interface. And then let's go ahead and put this inside the services. So services, go down to J, and then this will be product service, like that. Hit enter. We have our interface, and then here we're going to have product. And this will go ahead and be create product. And create product is going to take in a string name. And it's going to go ahead and take in a double price. And then it'll determine like what type it is from the server sets in. We're going to have a list of products. And this is going to be fetch. This is going to be fetch all products, and this is just going to be empty. We're going to have a product, and this is going to be fetch product by name. So fetch product, product by name with a string name in it. And then we're going to go have a product, and this will be update product. And here we'll have a product. And finally we'll have a void delete product. And again, this will be product and product. Okay, now this is going to have issues, so let's go ahead and import this. So space CA for code action, import product, space CA for code action, import that. Cool. And if we say space JO, it'll organize imports. It organizes on startup. So also apparently it didn't compile for some reason. :W, that's fine. Sometimes it just does that. Okay, so now I guess it's back inside of our services. So backspace FF. Let's go ahead and go into our services again. I don't know what happened here. So we have a product service interface. So now let's go ahead and set up the next thing, which will be our digital product. So let's go ahead and take a look at creating class. So space JC for create class. This will be in services. We'll say J, and this will go ahead and be digital product. Hopefully I did the other one correctly. I think I now in here, what we're going to go ahead and do is we are going to go ahead and say at service, and we'll go ahead and import that magically. We're going to say at qualifier, import that magically, and then this one will be digital product service. And this will help the controller know which one is which. We'll have to go and update the controller in a little bit. And then let's go ahead and use our lombok just to see that it works. So here, I'm going to say at required args constructor, and we're going to have a private final, and this will be a product repository. We'll just say product repository. So our lombok works, everything's good. And then here, let's go ahead and just bring in some of our methods. So we're going to go ahead and bring in our create product, which will just go ahead and do this, space CF for format. And then let's go ahead and space CA to import our product type, space CA to import our product. And then let's go ahead and bring in our fetch all product. So it's going to be very simple. So it's just going to be a stream, space CF to go ahead and format that. Okay, list doesn't exist. So go ahead and say space CA, go and import list from util, and let's see, what did I mess up? I need to say .get, or actually I just wrote this not in Java, so we're gonna say to a list maybe. There we go. I wrote this in like VS Code just randomly this morning, planning out what we wanted to do. Then we go ahead and fetch by name. By no means is this kind of like what you actually want to do for this. This is just fetch names by product W. Okay, space CF please, thank you. And then we just have two more. Normally I would probably say that you'd want like a default here, but this is not about the Java code. I just want to show you guys the code working and everything. So, or the configuration working. And then here, this doesn't need a return. So this is just a product repository :W, and then space CF. So again, very simple. I'm just kind of setting all this up so we can go ahead and see some of the other things. So now my next idea was to kind of show off trying to extract these to a constant. So let's go ahead and we see that we have product type.digital. So let's go ahead and see what we can do with that. So we've used this 3 times. So maybe we can go ahead and extract this to a constant, space, and then Shift J, Shift C. So now we can see we have this, and it even actually went through and switched all these to digital. So that one worked pretty cool. Let's see what else we might want to try here. Let's say that maybe we want to go ahead and whenever we fetch a product by a name, maybe we want to also go ahead and, you know, use this to do some other work. So we can go ahead and say space, and then we can say J and then V to extract as a variable. And here, let's say this one. And now we see our product, that's fine. And this has mattered us. Why? Because we have a duplicate. So we'll just say P or something. Not great naming there. But then we could do like, okay, and then fix these as well. So again, that could work a little bit better, but it did extract it to a variable, or I just named those really wrongly or not very well. And then here we could be like, okay, do more work on product, then return it, right? So we can also go ahead and extract things as a variable. Again, not a perfect example, but I just want to kind of show you guys the different things you can do with this. Let's go ahead and go back to our physical product service. So say space FF, go ahead and say physical product service.java. So here we'll say implements our product service. And some of these might be broken. So here we have a product type physical, and the other one space FF. So we go digital product service, we can see that's digital, so on and so forth. Space FF, go back to our physical product service. So that's good and fine. Here we'd probably want to update this, update a couple other things. Again, this isn't like supposed to be like a perfect thing here. I just want to kind of show you guys what's going on. So now let's go ahead and see kind of like some of the references and stuff. So let's go ahead and say space FF. Let's go to our controller. We only have one controller right now, so product controller. So now let's say, for example, we're like at the very bottom of this guy, and here this is going to complain unless we at least do this. So we're going to go ahead and say physical, whoops, if I could type physical product service, and then of course let's actually undo this. Let's say space C shift R, and we're gonna go ahead and rename this to physical product service like that. There we go. Rename all that. So now let's say that we want to see where we actually declared this product service here. So we can say space, and we can say C, and then D is go to definition. So we can go here, it takes us to definition, so that's cool. And then if we go back to our base FF, let's go back to our product service and then go into product service interface. Here, if we want to go ahead and see like what the references are, we can say space and then C and then R for rename, and then whoops, you should be able to see the references, or actually I want to see implementations, I'm sorry. So let's go ahead and say space CI, except that didn't quite do what I wanted, unless digital didn't actually. So let's space FF, the digital did I not actually implement? That would make sense. So let's go ahead and implement product, oops, if I could type product service and what's wrong. So we say space CA. What's the unimplemented method? Somehow I forgot fetch all. I have fetch all products. I typoed, yay, fetch all product, and then this refetch all product by name. So let me go ahead and fix this really quick. This isn't what it's about. All right, cool. So now space FF, go into our product service, space, and then CI. There we go. There's our two implementations. That's what I wanted to see. Cool. And then let's go back to our controller. Whoops, space FF. Go to our controller, and then go to our product controller. Here we can go ahead and take a look at, I guess what we'd actually want is this can stay a product service, and product service cannot be, let's go ahead and say space CA and import product service. And now we can go ahead and see everywhere this is referenced. So space CR for references. Right now there's obviously in product service and a couple other things. And then finally, let's see. So we basically went through like all the different code action stuff, everything like that. One other thing that we can go ahead and do is we didn't actually take a look at hover doc. So we go over to like REST controller and say space and then C and then H for hover docs. Apparently it doesn't want to work. Oh, there it is, just a little bit slow. So you can see that it kind of popped up some documentation there. And then I think the last thing that we kind of really want to do is go to a class. So if we go to, let's see, if we hover over our product here, so we have our product and we say space and then C and then shift D. It should take us to the product class, maybe. No, okay, it might have to be like this, space C and then shift D. Okay, I guess this one isn't working. This one should take us to the declaration. Maybe it just doesn't work as well with Java. I thought this had worked at one point. Let's make sure I'm doing it right. So space C and then shift D. So yeah, this one doesn't seem to be working. Play around with it. Everything else has been working pretty well. So now finally, let's go ahead and take a look at some other stuff. So finally, we'll go ahead to space FF. Let's go ahead and find our test. So Java test, product service test. Is this going to work? I have no idea. Technically, it should still be able to fetch it. But if we want to go ahead and run a test, I don't know if the test is going to pass. It passed at one point, but it might not pass now. We go ahead and say space. We can go ahead and say J, and then we can go ahead and if we want to test this specific method, we can say T. So it pops it up and it looks like we passed. Cool. So that's good. And then this is like the DAP UI. To close that, we can say space DC for close. If we want to go ahead and run the entire test suite or all of these, we can say space, and then we can say shift J, shift T, and then of course there's only one thing here, so it's just going to run that get test by name, but that's fine. And then finally, let's go ahead and take a look at debugging. So the cool thing about this is it even works debugging tests. We can say space DT to toggle breakpoint. You can see there's a breakpoint there. So now if we want to go ahead and run this test, I don't know why it didn't quit, and maybe it did. Okay, it just looks like it's running. Things are a little bit wonky sometimes with the debug adapter. It is what it is. Space DC to close out of it. We can say space DS for debug start. It looks like it wants to work, so that's great. Sometimes sometimes it'll say, let's see, ensure you compile, unfortunately, or you know what? No, we had to run as a test. I was wrong. So let's say space DC. For testing, you have to say space and then JT to debug a test. So let's see. There we go. Cool. So it stopped, and you can do basically everything that you expect here. So it should allow us to step over. Again, this is a little bit buggy sometimes, but you have this, you have the fetch, you have the mocked, all of that stuff. And if we go ahead and continue, it should go and pass. You can do the same thing inside of Java as well. So if I close out of this space FF, maybe let's go to the service, I don't know, and go into our digital product service. Let's say we have a breakpoint here. We want to see what the product looks like or something, DT, and we can say space DS. If I type right, space DS, it should start up. Now, sometimes it'll say that it cannot find the main file, and I might have broken. Yeah, I guess it's not fully working. Again, I wasn't trying to get this working. I just kind of wanted to show you all like what you could do here. But whenever your application actually runs and everything, just to go ahead and debug and everything, it worked in the test. So that's good. So again, try to kind of run you through all the different functionalities. And then there's also all the other stuff that we talked about earlier. So let's go ahead and wrap this up. I know I've taken a bunch of you guys' time, and then hopefully you guys can get into Vim just like I did. Alrighty, y'all. So I'm going to go ahead and make this outro short and sweet. I know I've already taken a lot of you guys' time. Hope you guys did enjoy this video. It took me a lot of work to go ahead and get all the configurations figured out. I had to debug a whole bunch of stuff when it came to the JDTLS and everything like that. So hope you guys do appreciate it as well. Then a lot of the other stuff I'm just going to go ahead and be bone stock. That way you guys can kind of explore and experiment and kind of do whatever you want with that. So with all that being said, if you guys did enjoy this, it did take me like 3 days to go ahead and record all of this. It's probably going to take me a couple weeks to go ahead and edit all of this and get this down to a decent length. That way it's not super long. So if you guys did appreciate the knowledge or did enjoy the video, please leave a like, comment, and subscribe. I don't like asking for it at the beginning of the video, but if you made it to this point, you've been pretty invested and I appreciate it. So yeah, with that being said, I hope you guys enjoy the configuration. If you guys want to see like the fully up-to-date configuration that I'm running, you can go ahead and go to the description down below. I'll go ahead and link what I'm currently working on. It's going to be based off this with just some tweaks here and there, so you guys can follow along with that as well and add anything that looks interesting to you. So with that being said, as always, I appreciate you guys for stopping by the video. I appreciate all the likes, comments, and subscribe, all the other support that y'all throw my way. I definitely appreciate it. Never thought I'd be at this point. As always, it's Ethan, your favorite underqualified senior software engineer, or otherwise known as unknown coder. And with that being said, I appreciate y'all, and I'll see you guys in the next video.